Very good morning to all of you. We will be starting with the day two of our virtual conference on bridge construction in Asia shortly. We will be starting in another 4-5 minutes. Thanks for your patience. Morning, everyone, and a very warm welcome to the day two of our second edition of virtual conference on bridge construction in Asia. We are now ready to begin the day two proceedings. Just like yesterday, we have about 7 sessions planned for you today, and I'll quickly let you know about what those sessions are. We have a project showcase on Cebu-Cordova link expressway, which will be presented by Metro Pacific Tollways Companies. There's going to be a session on focus on integration of survey plus BIM for bridge digital construction, where we'll hear from Leighton Asia, Hong Kong. There's going to be a session on Australasian experience on the use of weathering steel bridges, where we'll hear from WSP. There'll be a session on focus on methods of bridge construction projected by Jacobs. There's going to be a country focus on Sri Lanka, where the presentation will talk about bridge construction project over the Kelani River. There's going to be a session on bridge repair and rehabilitation, and we will conclude with a session on bridge construction experience, challenges, and key learnings by L&T Construction. But before we begin today's proceedings, we will start with a brief presentation from our site, which is going to be presented by my colleague Ishita Gupta. Ishita is an associate director with us, and she basically looks after urban transport and urban development domains. She comes with 7 years of work experience and also holds a master's degree in economics. Ishita, you can start sharing yours.
Yeah, thank you, Gaksha. Good morning, everyone. Just a quick recap of yesterday's proceedings. I hope my screen is visible.
Yes, it is.
Okay. So the day began with trends, developments, and outlook. Economic growth has improved bridges infrastructure in the Asian region. Presently, 9 out of 10 world's longest bridges are in Asia. For transport integration, transport hubs, autonomous vehicles, multipurpose bridge, and transport corridors are being constructed across the region. Precast segmental construction leads significantly to reduce transportation issues, while removing the need for casting a top slab. Advanced analysis techniques enable the designer to model the design of the completed bridge, the stresses in the bridge during the erection process, and the geometry of the bridge during construction. Some of the challenges are constructing new highway over existing roads, limited space, etc. Adoption of smart bridges will transform the way bridges are constructed going forward, and artificial intelligence and machine learning will be used for bridge design and maintenance. The next session was experience best practices and challenges, focus on the Philippines. Bataan-Cavite Interlink Bridge is an upcoming bridge which will provide permanent road linkage between Bataan and Cavite. The 32.15 kilometer long bridge will have 4 lanes, 2 lanes in each direction. The bridge is divided into 7 separate packages. Package 4, which is Marine Viaduct, is the longest package, spanning about 12.6 kilometers. BCIB specialty studies include onshore geology, hydrodynamics, aesthetics manual, etc. And also site investigation includes onshore topography and bathymetry surveys, onshore geotechnical investigation, offshore marine bathymetry, and geophysical survey. The next session was project focus on Chenab Railway Bridge construction in India. The Chenab Railway Bridge will be the world's highest railway bridge, spanning about 13,015 meters. Incremental launching of deck structures on combined circular and transition curve was done for the first time in the world. Topographic model study and aerial elastic model was undertaken for the project in addition to fatigue design and detailing of the bridge. The world's largest capacity crossbar cable crane has been used for erection of piers, trestles, and arch segments. The biggest challenge was to launch the bridge incrementally on a compound curve instead of transition curve and a circular curve. Another challenge was related to logistics management practices. To overcome the challenge of erection activities, advanced life care systems have been installed for safe work platform. Also, inspection of scaffolding is being carried out prior to installation. The bridge is expected to be completed by the year end. The next session was on innovative designs adapted in the 19.3-kilometer Brahmaputra Bridge. The Brahmaputra Bridge project aims to provide strategic connectivity between Assam and Meghalaya. The bridge spans about 19 kilometers. The approach embankment is about 0.9 kilometer, and the number of lanes are 4, along with 2 additional emergency lanes. The emergency lanes have been separated from the main carriageway with aid of double continuous lines and provision of armadillo separators. The foundation includes wells for main span and board cast in situ piles for viaduct spans. The bridge is being partly funded by JICA. Some of the features include emergency response system and flow monitoring system, boat ambulance, retractable stairs for access to the bridge during floods emergencies, CCTV, electrical substation, etc. IWAI conducted a physical model study of the entire bridge, while the Central Water and Power Research Station performed hydraulic model study. The expected date of completion of the project is about 2028. Is the next slide visible, Akanksha?
Yes, now it is.
The next session focused on Pitrani project in Indonesia. The Pitrani project commenced on in April 2018 with a duration plan of 884 days. The toll road length is 4,375 meters with 4 lanes of 3.5 meters each. The project is the only city elevated toll road in Indonesia without land acquisition. The toll road will shorten travel time to reach Sultan Hasabuddin International Airport and improve distribution and logistics delivery. The project uses latest innovations like flying pierhead formwork system and balance launching entry on the box per direction. Also, to monitor the structural condition, structural health monitoring system has been introduced for the project. During the construction period, the project achieved 0 fatal accidents. The last session was bridge projects in the GCC. Some case studies were highlighted during the course of the session. Etihad Rail 2C comprises of the Desert Mainline C Railway Bridge, which is approximately 550-meter long, and the Jebel Ali Branch Line Railway Bridge, which is almost 1.3 kilometer long. The construction involved 22 stages, starting from construction of concrete pedestals with anchor bolts to remove scaffolding after completion of welding and painting. Some of the main design considerations are span optimization and standardization, soil structure interaction, durability, etc. Another case study was the SAR interchange flyover, which has a total length of 515 meters. The design was carried out according to AASHTO LRFT Bridge Design Specifications 2012. The highway design required a constant crossfall of 5.4% along almost the entire bridge length. Top slab was constructed using an adjustable formwork system so as to cast it at the required level and with the required crossfall. Top and bottom flange non-concentric pre-stressing tendons were used, enabling the removal of traditional second stage pre-stressing and simplifying construction. Thank you.
Thank you, Ishita. For a quick recap of yesterday's sessions, we are now ready to begin with today's proceedings. And as I mentioned, the first session is going to be on project showcase on Cebu-Cordova Link Expressway. For that, we have with us Mr. Herbert Leboy, Vice President and Project Manager, Cebu-Cordova Link Expressway Corporation, Metro Pacific Tollways Company. Before I invite Mr. Leboy to present his views, I will quickly introduce him for our audience here today. As I mentioned, Mr. Herbert Leboy is currently the VP and Project Manager of the Cebu-Cordova Link Expressway Corporation, a wholly owned subsidiary of Metro Pacific Tollways Corporation. He comes with 3 decades of construction, engineering, and project management experience. Mr. Leboy is overseeing the construction of a new iconic landmark in the country, the Cebu-Cordova Link Expressway project, which is an 8.9-kilometer toll bridge that will link mainland Cebu from the the South Road properties in Cebu City to Mactan Island through the municipality of Cordova. Previously, Mr. Laboy has served briefly as Office and Field Engineer of the Philippines National Construction Corporation as well. Mr. Laboy is a civil engineering graduate and he's also completed Masters in Management and Business Management at the University of the Philippines. Welcome, Mr. Laboy.
Thank you, Ansi, for the introduction.
So the structure of the session would be such that I would request you to share your presentation first, and then we will take up questions from delegates. And my request to all the delegates is to please keep sending your questions and comments in the chat box or Q&A tab while the session is in progress, because that way it will help us take more questions from Mr. Laboy. Mr. Laboy, please.
Thank you, Ansi. I'm sharing my screen. Can you see my screen now?
Yes, sir, we can see it.
Okay. Thank you. Shall we start?
Sure, sir. Sure. Please
Okay.
go ahead.
On behalf of the company, the Cebu-Cordova Link Expressway Corporation, we'd like to thank the organizer of this virtual conference, of course, India Infrastructure and its support and sponsor. I'll be presenting our just completed project, the Cebu-Cordova Link Expressway project. Just a snapshot of the Cebu-Cordova Link Expressway. So you'll get the feel or the picture of the of the project. Let me start with the project information of the expressway. It's a short introduction. It's called Cebu-Cordova Link Expressway, and it's Cebu-Cordova Link Expressway Corporation, a Metro Pacific Tollway Corporation subsidiary, is the concessionaire. It's a PPP or joint venture agreement with the local governments of Cebu City and Cordova with a concession period of about 45 years. As to the features, later on we'll see more of those features. It's about 8.9 kilometers, which includes the main bridge, the approach viaducts, and the causeway. 2 lanes in its direction. It's a divided expressway. And the main bridge is a cable-stayed twin single pylon with a design speed of 80 kph at the at the expressway, and 60, a little less than, at the approaches. The main span of the main bridge is about 390 meters, with the pylon maximum height of 145. The navigational clearance, which is the clearance from the water to the bridge deck, is about 52 meters. And the horizontal clearance is 260 meters that will allow a vessel to pass underneath. It will be accessible to all vehicles, of course, except overloaded trucks and motorcycles. We also have sidewalk, a separated sidewalk on both sides for bicycles and pedestrians. So the proponents are, of course, us, CCLEC, the owner. We engage Cebu Link Joint Venture as our general contractor, as our APC contractor. That's composed of 3 companies: Acciona, which is a Spanish company, and 2 local companies in the Philippines, First Balfour and the M. Consoldi. The Cebu Link Joint Venture of the contractor engaged Siner and Carlos Fernando Casado as its designer. And on the part of CCLEC, the project owner, we engaged COE-DCCD as our owner's engineer and technical advisor. COE, of course, is a Danish firm, and DCCD is a local firm in the Philippines. As a requirement of the grantors of the government, we engage an independent consultant, which is the Norconsult Management Services Philippines. Norconsult is a Norwegian company. And the grantor, of course, as earlier mentioned, is the cities of Cebu and the municipality of Cordova, both in Cebu. So as to its location and the site plan, The CCLX crosses the Mactan Channel connecting Cebu City via the Cebu South Coastal Road at the South Road properties to Cordova via MCR, the Mactan Circumferential Road in Barangay Pilipo. It is about 7.5 kilometers from the Mandawi, the first bridge, they call it in Cebu, and 8.9 kilometers from the second bridge or the Marcelo Fernan Bridge, which crosses the Mactan Channel. So that's why they call us also as the third bridge or the third link from mainland Cebu to Mactan Island. The alignment when we start from the Cebu City side, the Cebu South Coastal Road off and off ramps. We have the off and off ramps there. Then we get into the Cebu Viaduct and the main bridge, then Cordova Viaduct that brings that down to the embankment level. Then we have the causeway, which is about 5.5. This is about 5 kilometers, and we have 4 low-level bridges, totaling about 600 meters. At the causeway, there are vent pipes at almost 100 meters apart. That's basically to take care of the flow of water. So the total length of the road of the expressway is 8.9 kilometers. So alignment, the slide shows just the alignment components. We have the structures from the ramps to the Cordova Viaduct. Then we have the causeway or an embankment fill to the end of to connect to land in Mactan Island. And as mentioned, we have low-level bridges along the causeway portion. So this is the main bridge overview. If you can look at the slides, this basically explains what's the main bridge is all about. So it's a twin single pylon cable stayed bridge with 14 cables in its side, totaling to 58. It's a single fan cable, meaning that the cables are at the center. It's not on both sides, it's at the center. So it's just a single fan cable stay bridge. So these are the backspan supports, is 1 and is 2 and is 3 and is 4. Tower 1, Tower 2, and the navigational clearance. Down below is the Mactan Channel where big boats can pass. The main iconic feature of the bridge is the lighted crosses on the top of the pylon. There are 8 of those, 4 in its tower on all sides. So the slide will show the picture at night. If we look at the main bridge plan and the section, that's it's shown in this slide also. The typical cross section, the main bridge is of course a box girder types with steel struts inside to support the deck. On the approaches, meaning the viaducts, we have in-new girders as the support to the decking. And the causeway is the embankment fill is contained by gabions, after which armor rack are placed as what you call this, slope protection. Since it's an expressway, it's being operated, and our operating and toll equipment would include for the main bridge monitoring, we have stay cable accelerometers, GPS geometric controls, expansion joint movement sensors, and of course the roadweather information system because the bridge is a bit higher. For vehicle and traffic management or collection and operations management, we have, of course, 4 toll lanes in this direction. We're going into cashless RFID electronic payment options. We also have emergency parking areas every kilometer on the causeway, and variable message signs. We also have way in motion at both entrance, meaning one in Cordova side and one in Cebu side, and IP-based speed cameras and security closed circuit television cameras. Those are operated at the CCLX Toll Operations Center, which you can see down here. This is the Toll Operations Center. In constructing, during the construction, or in the preparation of the design, parameters and basis includes design life standards for structures. You have 50 years, for Portland cement concrete pavement, 20 years, and asphalt concrete pavement, 10 years. The main bridge was designed to sustain a maximum wind capacity of 200 kilometers per hour and maximum ship collision capacity of 110 meganewton. As to code basis, we have our very own Department of Public Works standard specifications and design guidelines. But for the main bridge, for the cable stayed bridge, we also look at other international standards like the ASTO, the EOS, and all those other specifications and code basis as supporting documents. If you look at construction method and methodologies and technologies, of course, it's an offshore pile construction. The contractor uses a barge during the concrete during the board piling works. For the towers, they employed the climbing formworks to build the main bridge towers as well as the other piers of the Cebu, particularly the Cebu Viaduct and the Cordova Viaduct. For the bridge deck, we have formed travelers, and it's about the traveler moves every 6 meters in the main span and about 7.15 meters at the backspan side of the main bridge deck. In the ramps and the Cebu Viaduct, Acciona specifically designed for this project the girder launching gantry used to lift and install in new girders high above the deck of the approaches and viaduct. The gantry is used at offshore locations where there is no ground available to use typical tandem crane installation of girders, and of course because of the height, we have to employ the girder launching gantry. So the contractor, fabricated specifically for Cebu Viaduct and the ramps. As to the stay cables, cable sizes varies from 68 to 118 strands per cable. It's shown in the slide. For girders, we use the new girders which are developed by the University of Nebraska in the States. It's the first project in the Philippines that are used in new girders. They are a derivative of the ASTO girders also, but in-new girders are a bit slender and can accommodate longer spans than our ASTO girders. We also employed demolition robots for used to demolish the overcast concrete piles, which would be, of course, difficult to perform using typical jackhammers. Our pile diameter in the main bridge is 2.5 meters, and there are 42 of them. So demolishing the overcast concrete might will take time will be longer will be longer when we use the typical jackhammer. So that's why we employ the demolition robots. It's basically remote controlled jackhammers. Due also to the bigger diameter of the pile, we employ the Osterberg cell test. It's an effective alternative to the pile dynamic analysis test, which is commonly used. Cross-hole sonic logging tests were also conducted. That's basically used to check the homogeneity and integrity of concrete in the piles. All main bridge piles were logged with 50% of the remaining piles randomly selected as per the requirement. That's basically to check the integrity of the concrete inside the pile. The longest board pile that we have in the project is about 60 meters. So we have to conduct the cross-hole sonic logging tests. For design, we have considered the project, or designer considered 3: vessel collision, wind tunnel testing, wind tunnel test, or wind tunnel basis based on based on the wind, and the causeway or the armor rock or the rock fill slope protection were also testers also conducted by using a 2D physical causeway testing. What they do, these tests were conducted in Madrid. What they do is they prepared a scale model of the structure and test it. We also have the seismic hazard assessment performed in order to develop a site-specific seismic design, acceleration response spectra, and input seismic acceleration time histories, which will be used for the three-dimensional linear dynamic analysis of the bridge in accordance with DPW's LRFD seismic design capacities. The study would show that the main bridge can withstand a moment magnitude scale of 7.75 with the earthquake epicenter located about 119 kilometers away from the bridge. So those are the studies that were conducted in the construction of the main bridge. Well, as in any project, of course, the impacts and the benefits for constructing one. In our case, CCLX will strengthen the capacity of the network of roads in Cebu. It will drastically cut the travel time to Mactan Cebu International Airport from Cebu City, and also from those coming from the south of Cebu province. It will sustain a linkage between Cebu and the Mactan Islands, and it will, of course, generate substantial savings to motorists by way of reduction in fuel consumption, transport cost, and vehicle operating cost. When we refer that to traffic situation problems in the island. I think that's all. Ansi.
Thank you, Mr. Laboy, for a very detailed presentation. We have a couple of questions from the audience, but before we go to them, I had a question for you, sir. If you could elaborate a little on, if you could just let us know about some of the challenges that you faced while executing this project.
Well, big projects or big magnitude projects like this will of course be from the from the outset very challenging. But one or more of the major items that we considered as problem during the construction. Mas of course we're doing construction in a marine environment. That's of sure. If we know, Mactan Channel is a busy channel where ships or boats passes. So we are not allowed to close that at any time during construction. So we have to work around that. We've been coordinating with all the government agencies and other institutions to follow the scheme. Another one is of course working in heights and in water. That's really, it's also a big challenge for us.
Okay, so there's another question from Mr. Sridhar. He's asking, in case of the O-cell test, in case the O-cell test fails, what would be some other tests that you would use to check the pipe integrity?
Well, I don't think if we can still have the pile dynamic analysis because of the diameter of the pipe. It's too big. We will be having a hard time finding a hammer that can be used to that. But as also mentioned earlier, we have, as far as pile integrity or homogeneity of the concrete inside poured during the construction, we conducted the cross-hole sonic to the cross-hole lagging sonic test to make sure that the piles are properly poured.
So you mentioned that the project is now operational. So what is your strategy on the structural health monitoring of the bridge?
As also mentioned, well, we started construction in July 2018, and we opened to traffic just last April 30.
Okay.
So for structural monitoring, we have expansion joint movement sensors installed at the bearing, so that will form part of the asset management exercise later on. We'll be setting up, of course, our own asset management to monitor, to structurally, as you're saying, structurally monitor the health of the infrastructure.
Right. So there's another question from Mr. Norman. The question is, what is the deepest board pile socketing to bedrock and the duration of the socketing to the design depth?
Well, they're saying Mactan or Cebu Island is basically coralline or coralline. So the bedrock, it's about 4-6 meters, with the water depth that it's deepest at about 14 or 18 meters, something like that.
Okay. So there's a question from Mr. Michael Wong, Leighton Asia. In the challenges addressed, was BIM implemented?
What do you mean? What's BIM?
Mostly in terms of digital. We have Mr. Wong here. Mr. Wong, can you hear me?
BIM is the building information management. Is is an information system that we try to first during this design stage, we already try to form a 3D model and then do all the simulation.
Yeah, in the case of the main bridge in CCLX, the contractor, the designer has prepared the model, of course. They have the model of the bridge. Remember, we have the wind tunnel test during construction. Yeah, they have the model to what you call this, to go to check the movements as to dead loads, as to profile, so things like that.
Okay, I see. Thank you.
So just for your information, Mr. Leboy, Mr. Wong will be presenting on BIM in the next session. We have
Okay.
another question from Mr. Matthew Mohan. The question is where to get the method statement for cable stayed bridge?
What's that?
Where to get the method statement for cable stayed bridge?
Well, that's the method statements are part of the documentation of the project that has to be prepared by the contractor. So we have all those, not just for the main bridge, not just for the stay cable, but for other structures also, or other. So we have the method statements.
All right. Okay. Sir, the delegates have also requested for your presentation. So in case you can share it with my colleague, Ansi Anthony, if you are comfortable sharing it with us, we would like to circulate it to them as well. Yeah,
of course. I can always provide. I'll just email it to you, Ansi.
Yeah, sure. With that, Mr. Leboy, we would like to close the session. Thank you so very much for your time, for being here with us today, and for a detailed presentation. I'm sure the delegates had a lot of questions for you, and I'm hoping that they were able to get the answers to those questions. Thank you very much, Mr. Leboy, for being here with us today.
Thank you also for considering and inviting CCLX in this the second edition of the Bridge Construction in Asia virtual conference. On behalf of Cebu-Cordova Link Expressway Corporation, a subsidiary of the Metro Pacific Tollway Corporation. Thank you very much.
Thank you, sir. Have a good day.
Good night.
We are now ready to begin with the second session for the day, which is going to be on integration of survey plus BIM for bridge focus on digital construction. And we have with us Mr. Michael Wong from Leighton Asia here. Welcome, Mr. Wong.
Thank you.
Yeah, sir, I'll just quickly introduce you for our delegates today, and then you can present.
Thank you very much.
As I mentioned, Mr. Wong is from Leighton Asia. He is the head of survey at Leighton Asia, Hong Kong. He comes with 26 years of experience in the domains of architecture, engineering, and construction. He has worked on over 20 plus major projects in Hong Kong, a wide range of infrastructure, building and railworks projects throughout, which involve construction of XRL West, Kowloon Terminus North, Hong Kong, Zhuhai Macau Bridge, Hong Kong Boundary Crossing Facilities, MTR South Island Line Tunnel, Austin Station, and Lok Ma Chau Terminus, DST Tunnel, T2 Sky Plaza, APM Tunnel, and many more such projects. He is mostly responsible for managing and planning all survey and instrumentation related works. Welcome, Mr. Wong, and please go ahead with your presentations.
Thank you. Good morning and hi everyone. I'm Michael Wong, Head of Survey and BIM Manager for Leighton Asia. Today, I would like to share the topic of the integration of survey and BIM, Building Information Management for the bridge, digital construction. First, I would like to share our company vision. According to the latest technology, the future construction ecosystem will be radically different. Customer centricity, data and insight, prefabrication, digital twin, ecosystem, innovation in material and equipment, smart procedures are all the critical essential elements for digital construction. Now, first of all, I will talking about what survey involvement. Spatial data acquisition is extremely important as the actual site and ground condition will dictate the design and the construction implementation. So in order to widen the spectrum of surveying, not only the total station, but also laser scanner and drone are being used in the different stages of construction. While surveyor play an important role in doing the design, crash detection, breach design. During the fabrication stage, we're doing some precast checking. During the construction, of course, surveyor doing the georeference setting out works, checking works. When the project complete, we're doing the as-built survey and the handover stage. We try to capture all the as-built spatial data. And also we try to implement all the as-built information to the as-built BIM. So for the digital construction, integration of survey and BIM, building information modeling, apply at every stage of the construction and the infrastructure process. And this life cycle benefit to the whole progress. So today, I would like to share our innovation part in our bridge construction for the Chiang Kwan O Lam Tin Tunnel project in Hong Kong. This part is for the realignment and demolition of the bridge purchased on the mountainside of the TKO portal. The upcoming slide will show the constraint that we face during the construction of the BMCPC footbridge and the method and tools that used to overcome them. There are two main topics will be present. The importance of the integration of survey and BIM for the bridge construction, and the selection and implementation process of the force work system. By using BIM, we obtain the benefit of the visualization 4D simulation model showing from the commencement until the completion of the TKO portal. The works involve large site formation excavation, and slope support, marine viaduct construction, demolition and realignment of the existing BMCPC footbridge. The final section of the work is the construction of the ventilation building that partly sit into the two of the largest caverns in Hong Kong. And now I will talk about the force work and the beam model used in this footbridge realignment. The new bridge is a 165-meter long post-standard bridge consisting of the three span. And the largest span, the central span, which will bridge over the permanent site formation area, which shown in white. This photo was taken in January 2017, where the upper site formation works has commenced. One of the major constraints in this site access, which is hardly shared with the public, and it is the access to the uphill cemetery. So there are times that the road is closed for weeks during to the religion festival, and we depend greatly on the marine transport. Other than the access, another challenge will be the space for construction. To overcome this, we reclaim a 50 times 50 meters marine platform for the material deliver, force work assembly area, and also disposal area, works. Another major constraint were the existing natural terrain. The slope where the force work foundation sit is approximately 70°, which result in numerous temporary cuts and subsequent support. The bridge also spans outside the permanent site formation. To minimize the damage to the original terrain and also considering the space required, we use 1, the truss type, 2, the lightweight forcework system, which require a smaller area for the foundation and can be assembled by hand. A detailed topographical survey by tow station, which clearly record the actual site and ground condition, is critical. For some inaccessible area, not only survey by the total station in a reflected mode, but also by the layer scanning and also by the drone for the aerial and optical photo capture. And then we will form a 3D reality modeling for further analysis. There are 2 areas that were completely redesigned based on the actual ground condition. Surveying by tow station and laser scanner, where combined with the drone scanning, make it efficient in the information to be feedback to the phosphor designer. We provide the site condition, phosphor designer redesigned, and provide the revised model. Back and forth information exchange with the 3D modeling between the several parties happened before and during the actual site works for the design coordination. While the BIM model was used extensively in the design stage, while the standard workflow will be first doing the survey and then carry out the forcework design, pass the information and double check with the 3D modeling and going to the site excavation. But sometimes we need to do more. The most complicated area is a 20-meter long truss, which was introduced due to the different rock head level that found during the site excavation. And therefore, we will try to carry out a more decent and more detailed survey by the drone and laser scanning in order to find the actual site condition. This tower E, in the original design, cannot be constructed. To minimize any tower sitting at the location, we then use a 20-meter long truss rather than the usual 12-meter long one, but which is leading to another problem. The forcework system was not strong enough to take the loading for both the U-trough and the deck core in this long span. We use a pop and repop system to transfer some of the loading into the built permanent structure between the pours. And here comes another example of the selection of a forcework system to fit the site condition. Large heavy-duty pop were introduced considering the incarnation of the rock head and the needs of the fitting the temporary slope profile for the whole road parks. As a result, the forcework were changed into 2 levels as shown. The redesign of this forcework occurred concurrently with the erection of other tower where the rock head level was confirmed. There are the both back and forth information exchange example through the BIM model. with the FOSWORK designer, which is greatly helpful when design updates are necessary to shoot the actual site and ground condition during the construction. So as far as possible, the FOSWORK was built and erected in a modular fashion. We then assembled the tower by hand and then lift them into the position with the crane. This is also have a safety benefit, as the working at height operation was only for the rigging and de-rigging. Niches were cut into the hollow slope, and the slope could be assembled out of the hollow area beforehand, so that the hollow can be always remain operational, which is the main advantage of this modular system. It was only when the truss were lifted and installed that the hollow will have to temporarily be held. The same principle was applied for the truss. Then we will able to obtain a safe and efficient method of erection. First, the light ring system. Second, inspection prior the lifting. Number 3, safety measurement prior the lifting. And also the 3D conceptual method statement. So other than the better design coordination, the 3D beam model was especially important for the on-site work in terms of communication. For example, in the FOSWORK dismantle work, it was used to initiate the discussion between the workforce to brainstorm and discuss the safest and most effective method. It is particularly useful as we can thoroughly think about how to implement all sorts of work, such as plan in detail the man access with the constrained headroom. The first snapshot show how we plan to move the truss, and the photo above show the site operation. The second show how the truss will check up to remove the callot plate so that the truss can be slid out the above completed construction area. There are just a few examples, but you can see the method that we use on site generally followed the beam model. This picture can be also used in our day-to-day basis and to form partly of the morning briefing during the dismantling. It is much easier to explain with an interactive sketch to the workforce than just by talking. Another advantage of using this snap in the briefing was that it provides a platform for them to raise their concern, which we could address. And other than the selection of the FOSWORK, the beam model also benefit to the construction planning. As mentioned, the bridge span outside the permanent site formation. Considering those areas, we not only simulate the bridge structure in the beam model, but also the actual size of the forcework system to be used. It helps us to visualize any obstruction to the structure and forcework selection such that we can prepare for any necessary slope cutting works. Estimation of time and cost of these additional works can be then well prepared. Besides, as the new bridge is an in-situ RC bridge, which will be constructed under the above mentioned site constraint, concreting works have to be planned extra carefully. With the help of the survey and beam model, we can able to get a very accurate concrete volume from each section. We then can evaluate the feasibility to plan the pour, that is, by the marine or the land transport. During the pour consideration, the limitation of the public access and the night hour works. And finally, this bridge are built successfully. So for conclusion, for the integration of survey and beam for the bridge construction, we'll say survey is important. It can upgrade to capture the site spatial condition. By applying the beam model, we can early discover all the problem and work out the solution. It costs the less remedial works. It enhances more efficiency communication, enhance the safety, promote the productivities, and develop accuracy. And of course, the most important, improve our quality. So here comes the end of my presentation. So thanks everyone. And let's move a step forward with our advancing construction technology. And this journey starts from you. Thank you.
Thank you very much, Mr. Wong, for a very informative presentation. We have about 5-7 minutes for questions and answers, and we have a couple of questions from the delegates. But before we move to those, I have a question for you, sir. I mean, you've spoken about a particular project and how BIM technology and digital construction has helped achieve, I would say, operational efficiency, cost efficiency. But what is your take on adoption of such technologies in other Asian markets? I mean, you spoke about Hong Kong here, but how are the contractors in other Asian markets taking to these technologies?
I think now BIM will try to involve in worldwide. We have another project in Indonesia, in Philippines. We also try to implement the BIM on the early stage, and we find the benefit because I would say the new project, we always have some challenging and some unexpected problem. So by using the BIM on the early stage, we can define the problem first and then try to resolve the problem first. Compare with some traditional construction work, we might sort of we start the construction work and then we wait until we have the solution, which that part will having some hold up on the whole project sequence. So by applying the BIM in the early stage, we can sort of tackle the problem beforehand and make the project more smoothly.
All right. Since there is a question from Mr. Raidel Saraf, he will be presenting next. He is from WSP. His question is, will this digital twin model be used later as a part of the asset management of different project structures?
Oh, yes. Actually, the the idea of the BIM is this is a whole life cycle. We aim for starting from the designer. He put his idea into the BIM, and during the construction, we using the BIM. We try to have the digital twin, make sure there is like single point of truth. The design is what thing we try to build, and we will capture all the spatial data and including the access code all put into the BIM. And this as-built BIM we will then pass to our client for their access management in the future.
Okay. So there's another question from Mr. Tirtha Roy. He's asking if we can have an idea of cost of incorporating BIM in projects as a percentage of project cost, basically. A ballpark figure, if you can give.
To us, subject to the project requirement, most of the project in Hong Kong now, the contract already write down the involvement of the BIM that it should be involved in. But in Hong Kong, like wherever the project is over 30 million, it need to be involved BIM. But they didn't mention how deep is the BIM should be involved in. Either it's only on the design stage, or this is the BIM that is for handover, is so far not be very clear defined yet. But as one of the responsible and main contractor, Leighton Asia, we always try to implement the BIM in order to capture the whole construction life cycle benefit. So we will have a BIM team, and for some project, if we can't delegate sufficient BIM expertise, we will try to sort of sublet the BIM service in order to able to capture the benefit of the BIM.
Okay, and Mr. Wong, as a contractor who is using BIM extensively, any thoughts on some focus areas that the BIM technology providers should focus more on, or certain pockets that you would want some kind of improvement in?
Actually, as I mentioned, the future construction ecosystem, we're thinking about not only the main contractor using the BIM, but actually is the whole supply chain, like some specialist contractor, some blockchain. People are getting involved in BIM. For example, I want to build a building where in there we have like 10 rooms, and each room we need to have like at least one air conditioner. So all this role, including the blockchain, they will have provide a BIM model. Oh, this is our new size of the air conditioner. So which is what is the actual size they are produced already in BIM. So it makes the construction really accurate and more efficient. So this is our hope in the future for the digital construction.
All right, Mr. Wong, thank you so very much. With this, we will close the session, and I would like to, extend our gratitude to you for taking out time and being here today with us to present your views. Thank you very much, Mr. Wong, for being here.
Thank you.
With that, we are now ready to begin our next session for the day, which is going to be on the Australasian experience on the use of weathering steel bridges. For that, we have with us Mr. Raid El Saraf, who is Technical Principal, Asset Integrity Management, WSP. Welcome, Mr. Saraf. So before I request you to present your views, I will quickly introduce you to our audience here. Just allow me about half a minute to do that. As I mentioned, Mr. Saraf is WSP's Technical Principal Asset Integrity Management based in Christchurch, New Zealand office. He comes with over 19 years of experience in durability design, corrosion assessment, rehabilitation, and asset integrity management of steel structures with a focus on steel bridges. Over the years, he has co-authored several publications on the durability of structural steel, which includes both the New Zealand and Australian guidance on the use of weathering steel in bridges. Welcome, Mr. Saraf.
Hello and good afternoon, everyone, and thank you for inviting me to attend this conference. Ra'ad Al-Saraf, WSP, based in New Zealand. As Ansi said, I am the Technical Principal Asset Integrity Management. And today, yes, we're talking about the Australasian experience on the use of weathering steel bridges. Oops. Hold on.
So we can
Yep,
see
there
your
you go.
presentation. Yeah.
Yep. Okay. Thank you. Okay. So we're going to have a table of contents. Just going to talk about what is weathering steel, the current available guidance in both New Zealand and Australia, the benefits of weathering steel, where to use it, limitation on its use, its availability, design and detailing, what you need to know, which is probably the most important thing in my view, in-service inspection, maintenance, and rehabilitation. So what is weathering steel? Weathering steel is a structural steel with improved atmospheric corrosion resistance. In a suitable environment, it may be left unpainted, as it formed a adherent protective rust patina layer. And as you can see from the graph here, when you have typical corrosion on steel, you form a layer of rust, and over time that layer falls off, and then you have a fresh piece of steel, and then rust forms again, and that cycle continues on, and that's how you have your corrosive layers. While with weathering steel, you have that first layer of rust forming in the right situation and environment, and when that occurs, that form a adherent layer of corrosion, which in turn impedes the access of oxygen and moisture on the underlying fresh piece of steel, and that's how weathering steel works. Now it does that by having a certain alloy mixture. So you can't assume normal mild steel will do the same. It won't just rust away. So when you do have a freshly fabricated, prepared weathering steel, as you can see from the image, it will have a rusty look. Architects love the rusty look. The thing is, it takes between 8 to 16 years to have the proper patina formation in the right color, and that's when you get that chocolatey dark color, as you see from the other image. Certain international guidance talk about 2 years, especially in North America. In my experience, that is a function of having a more polluted environment. But for Australia and New Zealand, it seems that our air is a little relatively cleaner, apparently. So it just takes a little bit more time for it to form. And the way it forms, it needs that wetting and drying cycles. So it needs to wet and dry to form that patina layer over time, and hence why it takes so long. These are 2 publications that I worked on over the years. So the one on the left is the Australian guidance on the use of weathering steel, while the one on the right is the one for New Zealand. The Aussie one was published in 2017, while the New Zealand one was initially published in 2005, and this is the second edition in 2020. Yeah, so that's what we use in both countries. So what are the benefits of weathering steel? Because you don't have to paint it. You don't have to paint it. You have a well-designed and detailed weathering steel bridge had the following benefits. Initial cost savings, again, through the elimination of the need to paint it. Reduce construction time, because even when you bring it on site, you don't have any paint touch-up or whatever you need to do. Reduce cost and time of maintenance. And again, the biggest cost for maintaining of a steel structure is refurbishing and reinstating the corrosion protection system, i.e. coating, so you don't have that. Environmental health and safety benefits, again, you don't need to paint on site, therefore you don't have to worry about people getting hurt or any of those site-related work. And of course, attractive appearance. Now, some people will say beauty is in the eye of the beholder. And a rusty looking bridge like this looks beautiful for some people and some people not as much. But this is an example of a relatively new bridge in 2017 in Melbourne, a pedestrian bridge at University of Deakin. And I don't know, I think it looks pretty cool and beautiful. Where to use it? The most important thing for the use of weathering steel is picking the right environment for its use. If you use it in the wrong environment, the patina won't form. You won't have the right environmental conditions for that layer to form, therefore will continue rusting away. So based on the research we've done and observation of everything we've seen, we say that you need to have the first year corrosion rate of mass steel, the equivalence of less than 50 microns a year, which is having a corrosivity category of a C3 medium or less to ISO 9223. Now, the thing you should be aware of, what I mean by here is that is both the macro climate, which is what a piece of unpainted steel out in the air getting rainwashed, that is the macro environment, but also you have to take into account the micro environment of where you have a piece, again, if that piece of steel exposed to the sea salt and the environment, but not rainwash, i.e. underneath a deck, that's when the total of both of those environments, it need to be less than 50 microns a year. So that's the underside of the deck is your governing factor here. Now, in Australia and New Zealand, we do have corrosion maps in our standards. We have AS4312 for Australia, which as you can see here on the left-hand side, showing you the environment around Melbourne. Again, these are both macro environments, and while in New Zealand, we have corrosion maps of both countries. So if in your country you have the ability or having such maps, that would be makes your life really much easier in selecting the right environment for its use. Having said that, we have been involved with the development of such maps. They're relatively easy to put together, but they do require quite a lot of data sets. So that's probably a separate conversation by itself. Now, the good thing is, until a couple of few years ago, for our countries, most of the weathering steel we have access what we would call conventional weathering steel. Some people know it as Core 10. In the last couple of years, for New Zealand especially, we now have access to the Japanese Nippon Steel coastal weathering steel, which allowed you to use it in the C4, C5 environment, i.e. much closer to the sea. So you have the 1% nickel coastal weathering steel, which is deemed to be suitable in a C4 high environment, and the 3% nickel coastal weathering steel, you can pretty much use it next to the sea in a coastal environment. And in Japan, they have bridges that I think the oldest one is around 30, 35 years now, and it's looking pretty good in that type of environment. Now, it's not bulletproof. Like everything else, detailing is very important, and you need to be aware of where you need to use it and with the limitation of its use. The number one thing is must not be immersed in water, be in contact in soil or covered in vegetation. The reason for that, you will end up with a higher time of wetness. Therefore, you're not getting that drying cycle. And as you can see here, this is the weathering steel sculpture in Auckland that was embedded in the soil, and we're just having what we call ring bark corrosion. This will happen whether it's structural steel painted with galv or whatever. It's a poor detail all over, and typically the way we deal with that is we say to people, you need to paint anything that's buried up to 50 mil above that interface, air interface. So don't do that. You need to have a minimum of 2.5 meters above water, especially not subject to significant wave action. Again, you want to have the ability to have a nice airflow around the bridge to allow for that wetting and the drying, in this case, effect as well. And again, it's a beautiful bridge, a product steel to use, especially for railway bridges, as you can see here. Continuously wet and damp conditions, not good. So the other requirements, the time of wetness. The time of wetness, if it's less than 60% of the time of wetness is when the humidity is over 80% at 9 a.m. in the morning throughout the year. So if you have your time of wetness less than 60% of the year, it's okay to use. Between 60% and 70%, certain conditions we need to introduce. You should again try and not let it be shaded from sunlight between 9 to 3. You need to have unobstructed airflow and no vegetation taller than 3 meters of the steelwork. Again, anything it's good detail, it's a good design to simply let airflow and keeping that, encouraging that wetting and drying cycles. Now, time of wetness, how do you assess it? Again, in New Zealand, we work with the meteorological service, the weather people, and they're able to put together a map of the country. Again, that's probably something that you can do for your country as well, to develop such a map, and you get an idea. So basically what we're doing here is coming up with design, the guidance for designers to easily know when and how to use it, which was what the whole purpose of the design guide to begin with. So you can just pick up the design guide and go through all these things that the designer needs to know, so that they can design it correctly. Tunnel-like conditions, if you use it as part of a tunnel system or underpass or whatever, again, have it over 5.3 meters. It's just to minimize the risk of water splashing up from cars going underneath, especially in countries that use salt for de-icing salts for their roads. That's not a good thing. Salt is not a good thing under steel. So having that high enough to minimize the risk of, salt water splashing onto the bridge is a good detail. Atmospheric pollution above P3 to ISO 9223. Again, it's all about sulfur dioxide. So if you have certain conditions where it's beyond those type of limits, probably not a good idea. Again, then the patina, this discourages the patina from forming. Availability in Australia, they only can only allowed to use, based on their design standard, the AS and the 3678 steel. So they're very limited to one type of steel, locally produced steel. While in New Zealand, we're happy to use anybody's steel. So we also have, in addition to AS and the steel, we also use the Japanese GIS grade and the European grade. For us, most from New Zealand, most of our steel is actually supplied from Southeast Asia. So whether it's from China, Korea, where else? Taiwan, I think. Yeah, anywhere. So we can go to Japan itself, for example, or we just go to China or whoever really have a good price to buy it. We are recently in the process of updating our steel standards, and we're now also looking at introducing ASTM A709, American grade of weathering steel, and it's just because it's much more readily available and produced, and we can get it for a better price. So from a design point of view, bridges, we design bridges for 100 years. Weathering steel, by nature of the patina, is a corrosion layer. So you need to take into account how much section loss that is expected over that life to be able to size up and design your members. So we have this for conventional weathering steel from different corrosivity environments. You can go up to 1.5 millimeter per face in a C3 environment. And again, you just subtract that from your cross-sectional area, and then you can design your member. While in a C4 and C5, the marine grade of weathering steel, because it's a much more robust system, you can go down and reduce that allowance to 2.5 millimeters. So in most situations, if your member is near capacity, it could be as simple as just going one size up in your steel sizing. This allowance is applied to the throat thickness of fillet welds and partial penetration butt welds as well. So you're probably going to have to beef up your welds as well just to take that into account. And for high friction grip bolted connections, sorry. Yeah, here we go. Full removal of the mill scale is required. So it's just to have a nice clean surface. It's a very standard detail. We're aiming for a coefficient of friction of 0.5, and all fang surfaces should be abrasive blast clean using non-metallic grit. And we specified that to a visual cleanness level of SFPC SP6, or what is also known as NACE number 3. Okay. Available weathering steel bolts. You can get weathering steel bolts as well, so you can get some from the States, ASTM A325, which is equivalent to a proper class 8.8, which is commonly used in Australia and New Zealand. You can get 10.9s, ASTM A490. Also get them from Europe, while the coastal grade, you basically buy them from the same supplier. They supply the welding wire and the weathering steel bolts, the coastal grade of weathering steel bolts as well. So you have a full package. But the whole idea is your plate is weathering steel, your welding wire is weathering steel, and your bolts is weathering steel, and your whole system will perform as expected. Corrosion allowance for bolts, you're not required for the bolt shank because that is well within the plates, and by the time you tighten it all up, it's pretty much a inert environment. And the sizing of the bolt heads and nuts are generally sufficient to allow for any section loss that may occur. They're beefy anyway. So this is a standard clause that we introduced now in the specifications, is just to make sure that you have it as clean. And pretty much, yeah, you just abrasive blast to a nice number 3 to remove mill scale and other contaminants. In the past, people used to say you have to grit blast, which is the same process we use when you use garnet, for example, to have a sharp angular profile on the steel. You don't really need that for weathering steel because you're not painting it, so you can use shot, and that is relatively cheaper as well. But effectively, the whole point of that is once you blasted it, you give it 3 cycles of wetting and drying at the shop. And the reason for that, you get a nice uniform finish on it. Because if you send it out to site with the mill scale, it will look a bit patchy for quite a while. And because what happened then is you have to get the mill scale, you have to wait till the mill scale itself falls off for that patina start forming. So what we do, post-fabrication, you give it a nice blast, you get rid of all the mill scale, and then that kickstart the patina process and give it a better chance of forming nicely and uniformly. This is another example of a freshly erected weathering steel bridge. General detailing. I'm trying not to rush here. So bad detail. Anything that is proud, especially with that type of wells, you have to grind it flush. You want to have that steel nice and streamlined to minimize the risk of water ponding, dirt accumulating, or anything like that. So it's all about getting it nice and keeping it as nice as clean as you can, discouraging any collection of debris, as you can see here. It's simply because once you have debris accumulating, it will get wet, damp. Then what happens is underneath that surface, you're just going to have that high time of wetness, and corrosion will just continue, and the patina won't really form. Rust runoff, again, it is a rusting product for a few years. So you need to have deflector plates effectively, the ability to divert any potential rust runoff away from your nice, beautiful, clean concrete abutment. So again, it's all about detailing, and we have all these type of little details that we incorporate into our design to minimize the risk of rust staining occurring, because it will rust stain, you have rust runoff for at least the first couple of years, if not slightly longer, depending on the local environment. So you just want to discourage that from happening. Interface protection. This is specifically, there's a couple of guidance here related to railway bridges. So when you have ballast in a cross section railway bridge, you need to put an additional coating layer, because again, you want to keep that interface relatively dry. For shop welded studs, now this is here talking about the top flange, and you have your shear studs on top, and you have your concrete deck on top of it. So when you have your studs applied at the shop, you fully paint that interface. And it's because unlike some people who tell me, oh, why do you need to do that? Concrete is waterproof. Concrete is not waterproof. Concrete will crack over time. Something will happen. Water will get through. And I deal with a lot of older bridges, like 60-year plus. And that's the biggest concern we have, is when water gets into that interface, and then that interface between the top flange and the concrete that start corroding, it is very, very difficult to fix. So it's a very simple detail of simply painting that top flange and give you that protection that you require. It's like a cheap insurance policy. If you do need to have site welded studs, now in New Zealand for the past 15, 20 years now, we pretty much shop weld our studs. We don't do site stud welding anymore. But if you do need to do stud welded on site, apply a edge protection with additional coating. You have a strip of unpainted bit in the middle, so you are allowed to be able to weld the studs on site. And again, we're just trying to give that chance for that when that concrete deck goes on, you have a little bit of protection to stop any water mitigation and crevice corrosion from occurring. Elements embedded in concrete, not to be coated. Yeah, you don't have to coat it except for that 100 mil below and 50 mil above. So 100. So if you have anything like an integral bridge at the abutment, 100 mil into the concrete, you should paint that, and 50 mil beyond that, you should paint that as well. Everything else not painted. And it's a very similar detail to what I showed you earlier. When ground planted steel, you typically have that interface as a risk of corrosion happening. Again, when you're dealing with coatings, we always recommend that a qualified coating specifier is used to prepare, review the coating specification. And this is an example of a ballast bridge, and you can see there's a product, the yellowish whitish color, that the product called Eliminator from Sterling Lloyd, for example. It's a waterproofing membrane that goes underneath the ballast, again, just to protect that steel. And you need to have the proper, drainage detailing and so forth underneath that, which I think I'll touch upon a little bit. Here we go. Drainage. Here's a poor detail. This is a relatively new rail bridge, and you can see they have these really small drain pipes. Unfortunately, they should have extended a little bit beyond the beams. So what happened here is water comes through and it splashes all over the beams underneath. So it's not a good detail. Just detail it right. You just need to keep them as dry as possible. So something like that, just simply extending the drain just beyond where the girders are would have been sufficient. Consider alternative drainage, coating, or doing something else. One of the issues of that, what I just showed you earlier, is they butted these plates, but they didn't do anything like welding them or whatever. So the coating can only flex so much. I thought that was a poor detail personally. They could have done it in a better way. So these things, they do need to be inspected and serviced. Like any other bridge, if you have a leaky expansion joint, which is probably the biggest risk, honestly, from what I've seen, fix that joint as quickly as you can. Accumulation of dirt and debris, so you have those deflector plates just to minimize that risk from occurring. Moisture retention due to overgrown vegetation, keep that vegetation area, especially around the abutments, relatively clear. Faulty drainage systems, condition of sealant at concrete steel interfaces, excessive corrosion product, pack rust, anything that encourages crevice corrosion, water from getting in, that causes a problem. And that's what, when you inspect such a bridge, any bridge really, are the type of thing you need to look out for. Loose bolts, obviously, graffiti damage. This is an interesting case from one of our projects. Got involved. It's a bridge. It's a weathering steel bridge in the UK, and over there they actually allow the use of conventional weathering steel relatively close to the sea that we do not allow. And this is what happened in that particular case. So all that white is actually sea salt embedded into the weathering steel, and the patina is struggling to form. It's so bad that the salt levels were ridiculously high. So it's not a good idea. I would not recommend using conventional weathering steel in an environment beyond SC3. Pretty much once you're pretty close to the sea, you should use either a painted mass steel option or a coastal grade of weathering steel. We do recommend monitoring the formation and color of the protective patina over time. So as I showed you earlier, you got that rusty red color when it's fresh and new, and over time it will turn into that chocolatey dark color. And once you pretty much get to that color, you had that patina is fully formed then. It does take between 8 to 16 years, depending on your local environment, stability to wet and dry and so forth. It's an interesting one, measuring steel thickness. We have a number of people say, as part of your monitoring regime, can you please measure the steel thickness so we can know where we are within that section loss? Are we still within the 0.5 or 1 millimeter or 1.5 millimeter per surface? So what we've done before is we've specified specific locations on the bridge, and you have to go back every few years and just measure it. So every 6 years in a C3 plus environment, every 12 in a C2, simply because the C2 environment is a low corrosivity environment and its corrosion rate is very, very low. So nothing much happens unless there is a leaky joint, which is not good. And you should do it with an ultrasonic thickness gauge or calipers where possible. But we have introduced lately a different way of introducing coupons of the same grade when they do build the bridge. And that allows you to remove them in the future and take them to the lab and test them without affecting or damaging the bridge itself. And you can attest it to ASTM G1. It's a much, in my view, that's a much easier way. And you have the ability to, you basically have enough coupons like 20, 30 or whatever it is for that period. Every time you go over there, you can take them off and inspect them, test them. Detection of fatigue cracks, again, just get a qualified welding inspector, visually inspect it for potential locations. Again, if you're familiar with bridges, you know where the at-risk locations are to be assessed, and you can use mag particle or visual inspection as well. We're nearly done. Maintenance, like I said, leaky joints, repair them. Periodic removal of vegetation from the vicinity of the bridge. You clean your drains and dam pipes. A general upkeep of the bridge, keep it clean. In the event of pack crust of a crevice, this is typically not an issue in like splice joints, but I've seen it happen when you have like a sign on because it's not tensioned the same as a splice connection. Then yeah, you clean it up and then you put a sealant around the edge to, and again, it's to minimize just the risk of water getting in. Remove loose debris where you can with just air or vacuum if you can. Removing graffiti. In the past, before I got there, in the past, people used to hit it with 10,000 psi. We found the pressure we need to go to that level of pressure, 10,000 psi, to effectively strip that patina to remove the graffiti because the graffiti embeds itself into the paint itself, into the patina layer itself. But we have found a product. It's an alkaline poultice. New Zealand, Australia, it's called Peel Away. It's an alkaline product, a paste on a backing tape. You put it on, you read the instructions, follow the instruction block, you leave it for 24 hours, and then you can peel it away, and the graffiti comes off with minimal damage to the patina itself. That has been tested and tried by Network Rail, so they've done a lot of research onto that. Or just leave it if it's not objectionable. Some people like it these days to graffiti all over the place. They call it art. Rehabilitation, sealing of grow crevices. Again, it's all about water getting in and to minimize the risk of unseen section loss. Remove the poorly forming patina layer when by wet or dry abrasive blasting. This is where, especially in situations where the patina is not really forming, that it was put in the wrong place to begin with. If that happens, the beauty of it is you can just take everything off and paint it like a normal steel bridge, and then it will perform the same. But yeah, followed by the application of a protective coating system. And then really inspection maintenance of a coated weathering steel, the same as a coated carbon steel, you just treat it like a normal mass steel bridge. So in conclusion, a well-designed and correctly detailed weathering steel bridge in the appropriate environment can provide an attractive, very low maintenance economic solution, and so extend the scope of a cost-effective steel bridge. Thank you.
Thank you, Mr. Saraf, for a wonderful presentation. It was very detailed, and we have a couple of questions from the delegates here. So we'll spend another 3-4 minutes on those. So we have a question from Mrs. Darshika Jayashekhara. She is Director, Road Development Authority in Sri Lanka and is one of our speakers. She'll be speaking later in the day. So she's asking, is weathering steel bridge a good solution for coastal areas?
If you use the right grade of weathering steel, the coastal grade, then yes, it is. So for us in New Zealand, we need to have a time to first maintenance of a steel bridge of 40 years, which is much more stringent than other countries. I know other countries have 25 years, so they allow like 4 maintenance cycles over the 100 years. Well, we allow 40. To achieve 40 for us, we need to go to metal sprays. And so you imagine in 40 years' time, the costs to, especially nowadays, environmentally, it's getting much more stricter to abrasive blast on site. Access costs is getting expensive, containment and so forth. So if you have the ability to design and specify a coastal grade of weathering steel, then yes, because you don't have that future maintenance cost of a steel option. The beauty of steel is it's easy to inspect. If anything goes wrong, you can rectify it. If you need to strengthen it, you can weld more. But yes, it's a good option in my view.
Thank you, sir. So there's another question from Mr. Sama Srinivas. He's asking, any specific type of welding electrodes to be adopted for weathering steel?
Yep. So you do have weathering steel electrodes. Like I said, the coastal grades, Nippon Steel who supply. So where you buy your coastal grade, for example, from Nippon, you can buy the specific electrodes for that. Same thing for conventional grade. So the guidance we have, if you buy AS&ZS weathering steel, European, GIS, whatever, you go to the same you then use the corresponding welding standard for that grade. Do not mix grades of steel with different standards of welding. And then each one of these standards have the corresponding correct welding procedures and the correct electrodes and so forth to follow. If you do mix and match, we have a problem.
So there's another question from Mr. Ghoshal. Actually, there are two questions on the same topic.
Yeah.
They would want you to cite the difference between weathering steel and stainless steel. And
Yep.
the second part of the question is that approximately what is the difference in the price percentage of both, basically cost
Yep.
consideration.
So actually, I do have another paper on the use of stainless steel in bridges. I think stainless is a great option in the right environment. Stainless, no, I don't have the latest pricing, but like 316 stainless, for example, is typically 5 times the cost of mild steel. At the moment, depending on which fabricator I talk to, they can get me a mild steel, a conventional weathering steel for the same price of a mild steel. This is the prices in New Zealand at the moment, because especially in America, the prices between conventional weathering steel and mild steel are very, very similar because they produce so much weathering steel that they don't even differentiate. Sometimes they just buy normal weathering steel and end up painting it because it's the same cost. It's all but then again, I know that Australian supplied weathering steel is actually dearer than Asian supplied weathering steel. So as for stainless, yes, it is dearer. But then again, in the right environment, stainless for you, when you do a whole of life net present value calculation, is also the right solution as well. So they have been situations in Europe where they have a concrete in one of the islands in Majorca, I believe, the Galanda stainless bridge. If you're familiar with that, that's 2205 duplex stainless. They ended up going with that instead of a steel, or because the concrete option before that, within 20 years, they had to replace it twice. So in the end, they just bit the bullet and built a stainless steel bridge. So I think really it really depends on the situation and how aggressive the environment is. I mean, a few years ago, we didn't have access to the coastal grade. Now we do. So that does change the equation a bit. But depending on the environment, you need to do an optioneering survey, and checking the environment, and then you select the right solution for the job. I don't know if I answered your question, but yeah.
So there's another question from Mr. Gaharwar. He's asking how can we estimate the remaining fatigue life. So he's basically talking about the remaining fatigue life estimation of steel bridge, which is made up of weathering steel.
It's pretty much just like a normal mild steel. You just go to the fatigue cycle tables. From a design point of view, there's not much difference. The main difference is you have to beef up your cross-sectional area just to allow for that corrosion allowance. But from otherwise, it's pretty much you're designing like another steel bridge, really.
All right. Thank you, Mr. Saraf. I'm sure all the delegates would agree that this was a very informative and a very interactive session at the same time. If you will share your presentation with ANSI, we will probably, share it with all our delegates so that they can, of course, go back and, yeah.
Yeah, all right, I will do. Thank you. Thank you for having me.
All right. Thank you so much, Mr. Saraf, for being here with us today. Thank you for your time. Ladies and gentlemen, with that, we've come to the close of the first half of our day here. We will now be taking about 45 minutes break, and we will reconvene at 1:30 p.m. Singapore time and 11 a.m. Indian Standard Time. I would request all the delegates to please, come back 5 minutes before the prescribed time so that we can begin the second half of the day on time as well. Nancy, can we have that slide put on, please? Thank you. So we'll see you all at 1:30 Singapore time and 11 a.m. Indian Standard Time.
Welcome back, everyone, to the second edition of Bridge Construction in Asia virtual conference. We're ready for the next session with Mr. Suman Chattopadhyay. The session is on focus on methods of bridge construction. Before we begin the session, I'll just quickly introduce Mr. Chattopadhyay. Mr. Suman Chattopadhyay, Sector Head Bridges, Geotechnical and Rail at Jacobs, India. He has about 25 years of professional experience in the structural design of bridges, flyovers, and water retaining structures, industrial buildings, etc. He's involved in managing the delivery of global infrastructure projects. He was design lead for the Hyderabad Metro and Dubai Metro and proof consultant for New Ganga Bridge, Patna. He has also supervised several construction projects. He has worked both in consultancy and contracting environments in countries like India, UAE, and Nigeria. Mr. Chattopadhyay has a master's degree in geotechnical engineering from IIT Delhi. So, Mr. Chattopadhyay, the format of the session would be 20-25 minutes of presentation by you, followed by 5 minutes of Q&A. Over to you, sir. You can start your presentation.
Thank you, Ishita. Okay, good morning, everyone. Today, the topic of my presentation is recent trends in construction of bridge projects. In this presentation, I will cover what are the driving factors which is governing the construction technique or construction process at present in the world. I will talk about some example on accelerated bridge construction technique, which is followed globally at the moment. I will talk on digital innovation and technology, which we are following to sort of support the accelerated bridge construction technique. I will talk on the project procurement evolution, how the contract agreement, contract clause are evaluated over the years to support some of these construction techniques. I'll talk on some advanced building materials which we are now using in our construction, and I'll summarize some of the challenges we are facing in our work. So first I want to say what is the driving factors behind different trends nowadays in the construction industry. As you all know, United Nations in their 2015 charter has come up with 17 sustainable development goal, which is going to change the world by 2030 and to make it a better and more sustainable future for all people in the world. So many of these sustainable development goals are related to civil engineering sector, and that's how we have a big role to play in achieving the this United Nations sustainable goals, and that is behind basically the driving factor against all the new construction method and techniques that we are following. In the just a minute. In this pie chart, I am just presenting the CO2 emission country-wise. You can see that China is the largest contributor, followed by United States, and India is producing around 7% of world CO2 emission, which is also significant. And in terms of sector-wise, transport, building, and energy sector, which is predominantly our civil engineering sector, is contributing around 50% of the carbon emission in the atmosphere. So we have a big role to play in controlling this carbon emission, and that is the reason that the new trend in construction industry is coming to support those initiatives. So to frame the overall trend based on this to achieve the sustainable goals, all over the world there are it can be framed in 5 major bullet points. One is that net zero sustainability benefit linked to these SDGs or sustainable development goals will become the center to project outcome. So any project outcome will be judged by how much carbon, how much sustainable goals we are going to achieve with that. So some of this includes advanced building material, optimized design and materials, planning concerning sustainability and climate change, reduced construction time, refurbishment and maintenance stress on that. So this is the trend. Second trend, which is accelerating digital transformation. So all the companies all over the world are transforming to digital or automation space, to support these sustainable development goals which United Nations has given us. So some of them are BEAM, Revit, InfraWorks, Dynamo, CAD, 3D CAD sets, parametric modeling of bridge, digital twins to create a replica of the asset in digitally. So these are all, there are huge amount of work going on in that space. Productivity, yes, we have to optimize the productivity with various methods like automation and standardization, 3D printing, drone survey, accelerated bridge construction. So productivity must improve to support the United Nations Sustainable Goals. And the workforce needs to be diverse from different fields, not only from civil engineering sectors, and it has to be globally distributed and to take the best talent in the world in the project. And finally, value replacing volume as a basis of financial reward. So revenue will be based on how much value you are bringing to the project, both social and environmental outcomes, not that how much volume you are producing. So value will be the key to judge your revenue in the project. So with that, I want to talk about some example of accelerated bridge construction technique, which we are following in our day-to-day work in construction method, both design and construction. First of all, I want to summarize what is accelerated bridge construction. Bridge construction that uses innovative design, material, construction, and and cost-effective manner to reduce the on-site construction time, and which reduces the traffic impact time, improves long-term sustainability in the project. So that is basically the goal of accelerated bridge construction. It can be brought by technical inputs that like project planning, automation, different types of construction method, innovative construction method, and materials. And it can be from contractual side as well, like there are different kinds of contracts which contributes to support the accelerated bridge construction. So this is part of project procurement all over the world, and especially in United States, Federal Highway Administration has adopted this accelerated bridge construction as part of their procurement strategy. Now I will give you some example of this accelerated bridge construction which we have done in our company. Some of the project examples. So this is the project where in UK where we designed the PR collision protection works for a bridge of around 2.25 kilometers long with 42 meter span, and the navigational span was around 76 meter. But because of the smaller navigation span and the large vessels passing through the bridge, there was a significant risk which is assessed, and that's why the PR protection works was the requirement of PR protection was generated, and that's how the design was done. So Jacobs was part of this design, and around this is done by steel tubular pile and with precast pile cap, which is around 290 ton in weight, which is brought by barge and put into inside the piles, and the precast fender long section also to join with that, and there is a in situ casting after that. So this is a combination of precast shell and in situ casting of the pile cap, which brought down the construction time considerably. And in this project, we have followed the early contractor involvement procurement process, which also helped the project a lot in getting the objective of accelerated bridge construction. So at the end, we could achieve the completion of the project 2 months ahead of the schedule and with a cost savings of around 1.36 million pounds. So this paper is published in ICA journals. I have provided a link here. So if any detailed information is required, anybody can see that. This is the project which we are doing with L&T in Mumbai, where we are the lead design checker for Mumbai Coastal Road, where the group piles inside the sea viaduct were converted to monopiles, 3-meter dia. So that reduces the construction time considerably, because the group pile involves the construction of cofferdam and dewatering, and it takes a lot of time to do the group pile construction in a marine environment. So with the monopile, we could achieve a very fast construction for this project. And Dutch drilling consultant helped in L&T, subcontracted to L&T, is doing the construction of these monopiles. Some of the other projects where we have followed accelerated bridge construction is New Ganga Bridge. We are doing also proof checking role in that project with L&T and Daewoo joint venture, where precast segments with pierhead segment cantilevering out from the pier with extra dose cables, we could achieve a very efficient construction for this 10-kilometer long bridge. Otherwise, it would have taken a long time to construct this bridge. So it is quite faster construction with this kind of construction technique. It is similar to balance cantilever, where we have used similar construction techniques in other projects, but extra dose bridge can give us a bit more span. We can go up to 150 meters, 160 meter span, which has helped in navigation plus faster construction time. These are some of the general ABC construction method which we have followed in metro construction, be it Hyderabad Metro, Dubai Metro. You can see the superstructure segments which are casted segmentally, which is very common in India nowadays. Dubai Metro, we have used precast PR cap, which is also used in the Delhi Metro, which is basically precast shells with in situ infill, which makes the construction of PR cap very fast. Obligatory span obviously was done in Dubai Metro by balance cantilever method, which is also we could achieve a very fast construction with this construction technique. In metro concourse level in Hyderabad Metro, we have followed spine and wing concept at the concourse level, where center spine is constructed segmentally and then wings are attached to it with transverse processing. So this method is very popular now, not only in station concourse level, but for vehicular bridges also. So this is also a very good example of accelerated bridge construction technique, which is being followed globally. A few more examples like Khalifa Port precast bridge in UAE, where the full bridge is almost precast, right from the pier cap, the superstructure. Every segment is precast, where we could achieve this very fast construction for this bridge. The two other examples of precast pile cap, one is in Malaysia, another one in Australia, where we have used precast pile cap shell with the driven piles in below, and then filling it with in situ concrete, where we have achieved a very fast construction with this technique. Some of the digital innovation and technology which we are following globally is listed here. I will not go each and every detail, but some of them are like we are developing Python-based program which can write to Midas script, MCT script to run a very fast to model a bridge, a very regular bridge, very efficiently, and we can design the bridge within a very short period of time. We are doing 3D reinforcement detailing, which is being followed now globally. Also, we are following. We are calculating the carbon footprint based on quantity from directly from the model. So we have developed a workflow for that. So there are various initiatives we are taking in Autodesk and Bentley softwares. So the bottom line is digital innovation is taking a very center stage in all our work now in design space. I'll just briefly talk about the project procurement, how it has evolved over the years. Item rate contract, we all know that is a conventional bill of quantity contract. The EPC contract came up with lump sum fee, but the quantity risks with the private company, but it poses a huge kind of financial burden with the government. So then client thought of, or government thought of build, operate and transfer mode. So all risk was with the private companies. Some of the projects like Hyderabad Metro and some few other projects were built by that. But because all the risks are transferred to the private company, this didn't get much popularity in India and globally as well. Then government thought of viability gap funding of 20% to sort of support the private players in BOT contract, but that was also not enough because the most of the risks was with the private company and didn't get popularity as well. So recently we are seeing that there are many contracts with hybrid annuity mode which are coming up. Hybrid annuity mode is a very innovative contracting procurement where 40% of the project cost is being funded upfront as a capital cost by government, and rest 60% over a period of 10 to 15 years as per contract. So this reduces the financial burden on the government side upfront, and it was distributed over the years, and this reduces the risk proposition which was there in PPP, other PPP model. So that's why hybrid annuity mode is getting quite a popularity.
Mr. Chattopadhyay, we are not able to hear you. I think there's some network problem. He's trying to log in again. Yeah, yes, Mr. Chattopadhyay, you can share your screen.
Sorry, Ishita, can you hear me now?
Yes, you're audible now, and we're able to
Yes.
see your screen.
Okay. Sorry, there was an internet issue here. So, okay.
Mr.
So,
Chakraborty, actually, right now we can see your next slide and note section as well. I think so. We'll have to change this to display settings need to be changed. Yes.
okay.
Now
I'll
it's
do this. Yeah. So, sorry for that. There was an internet failure. So, what I was talking about hybrid annuity mode, which has got quite a popularity now because of the less financial burden with the government, and risk is also sort of shared with the government. Not it is similar to EPC contract where quantity risks with the private company, where all other risks is with the government. So that way, this hybrid annuity mode is getting quite a popularity now, and early contractor involvement is quite popular now in the contract, where the construction cost or project cost becomes much more farmer because of the involvement of the contractor at the very design phase. We have, I think, high-speed rail project is also followed that method of early contractor involvement. Globally, the data shows that early contractor involvement is saving around 10% on the project time, and about 7% of the cost of the project. So this is quite an amount which is that's why it's getting popularity all over the world, and this is being followed. Some of the advanced building materials which we are using in our construction projects, like we are using mixed design. Um, uh, we are using mixed design with microsilica so that to get a faster curing time, less heat of hydration. Then we are using GGBS fly ash also from material side. This is helping quite a lot in reducing the cement quantity. There are self-filling concrete where using bacterial pores. Bacteria produces a limestone type of material which heals the cracks in the concrete. So that is also quite popular now. Fiber reinforced polymer deck in mainly pedestrian bridges. We are using it in various places in the world. Ultra high performance concrete is getting popularity. This is still a research based product, but because of the high cost, it is still not used that much. But this concrete is also becoming popular because of the advantages it contains. And some of the other materials I have listed here. So basically, the bottom line is there are various advanced building materials which we are using in construction industry, and that is gaining popularity because, and that is helping to achieve the United Nations Sustainable Development Goals. I don't know why it is. Okay, now I have listed out some of the challenges we are facing in this industry nowadays. In the preparedness of procurement agencies are much lesser to sort of because to get the objective of the United Nations SDG, and to have the framework agreement and proper, the procurement agency or clients needs to be prepared properly. Otherwise, this is not happening. So that is important. Some of the projects is happening well, but some of the projects is lacking there. So we need to improve on that. Socioeconomic and political pressure is a big hindrance in this. Some of the projects are feasibility, viability are not are compromised because of these issues, where we need to improve so that we can achieve the goals set by United Nations. Improper pre-qualification and award. This is we are seeing in many major projects, pre-qualification, both consultant and contractor are not done properly, and the projects are suffering at the end of the day. So that needs to be done meticulously to some extent. Sometimes socioeconomic and political pressure is also there. So those kind of things is a deterrent for a good project planning and execution, and that is creating various faulty planning and design in various projects. Like some of the projects that DPRs are done without proper study or investigation, and that is going to EPC contract, where there are various claims are coming, project costs are not proper because of that. So various issues are cropping up due to that. So we need to improve there. So with that,
Sorry to interrupt. Just 2, 3 more. Okay, you are done. Okay.
yeah, so, sorry, Ishita, I have completed my presentation. And thank you very much for your time to listening to me. And thank you, Ishita, for giving me this opportunity to present. I'll be happy to take any questions that may come up.
Yes, so there are a couple of questions from the delegates. So one of the questions is from Professor Menak Ghoshal. He's asking, as far as bridge projects are concerned, valuation per se was not the norms, especially in India, in contrast with real estate development projects. But with hybrid annuity model in bridge contracts, do you think valuation for bridge projects can become a norm in the future?
Yeah, I mean, why this hybrid annuity mode is getting popularity is mainly because we have various EPC contract in bridge projects. Now, EPC contract is definitely the contractors are quoting based on the quantity estimation and based on a preliminary design, and but the whole sort of financial risk for the whole project is, and the burden is with the government upfront. They need to pay the full project cost within a period of say 2-3 years of project period, execution period, or maximum 3-4 years, based on the project execution time. So that is creating quite a burden on the government. So in case of hybrid annuity mode, you are paying just 40% upfront, and that way the burden is much less with the government, and remaining 60% over a period of 10 to 15 years, which is quite an advantage in terms of procurement of the contract. So that is the reason.
Okay. There's another question. Have you any data regarding carbon footprint savings in any of your project by using accelerated bridge construction technique?
Yeah, these are being done. We call it value plus in our company. We have developed a tool to measure that carbon footprint in a project, and sort of how much carbon footprint savings is there in terms of a particular construction technique or a procurement method. That is a sort of we have developed a tool, and this is being followed now in the company, but I am not in a position to answer exactly in project specific terms now for a particular project how much carbon emission is controlled, but that tool is developed already, and that is being improved also to measure this carbon emission in the project.
Okay. Also, in any of your project, has UHPC been used?
Ultra high performance concrete is still a bit research based mode, This is, though it is developed in end 1990, near to 2000, that decade, but because of the high cost, it is still not used globally. But there is a working group which is globally, which is formed to put various kind of pressure on the various regulators, and to summarize the advantage of that, but that material in construction. And we are thinking that in near future this material will be very much popular in construction industry.
Right. Also, what is the approximate share of UHPFRC bridges out of total concrete bridges being built in Asia or outside, basically in Asian countries outside India?
Yeah, FRP you mean, I think, not FRC, correct? FRP. FRP is, we have a team, specialized team who designs for FRP bridges. Still now it is used for some of the pedestrian bridges in Europe and Australia. In our company design I'm talking about. But this is because of the high initial cost, there are some deterrent against this bridge, but this FRP decks are also getting popular all over the world because from on sustainability front. So and this is being this is also becoming popular day by day.
Right. Also, another question from one of the delegates is, by placing the pier collision protection work, we are reducing the navigational path considerably. So is it done throughout the bridge length or only for the navigation spans?
This is done only for the navigation span, that is covering 3 piers. The navigation span was around 76 meter. The vessel type is around 3,500 DWT. If you search in the internet, it is around 100 meter long and around 30 meter in width. So sorry, 20 meter in width. So that kind of vessel was plying through that, and there was a risk analysis which was carried out with a speed. That vessel was passing below the bridge with around 12 knot speed in a high tide situation. So the driver's error was a part in the risk analysis which sort of governed the decision to take up this kind of pier protection work, to sort of protect the pier in a and in terms of reducing the waterway. Yes, it is extended toward longitude, towards the direction of the ship movements, not much in the transverse direction. So that way the waterway is not reduced that much.
Okay. Also, can you give us anchoring detail of the precast pier at the foundation level?
Precast pier or pile cap, you mean, or precast pier? Oh, okay, sorry, I understood that Kalipa Port precast bridge, I think he's referring to. Yes, this details I mean is developed with for that particular soil condition, and based on the scouring potential of that particular foundation, the detail is developed. We have that detailed drawing for that with our designer, and if required we can share. But yeah, I mean, this is proper anchoring and scar protection was carried out for the foundation, for that precast pier foundation, which is rested which is submerged to the crane and rested on the top of the bed, which is prepared at the seabed level, which is rock, and then with the protection of around the foundation.
Okay. Also, do technically monopiles are they less redundant in structural performance considering geotechnical challenges? And what are the safety factors considered in the design?
Yeah, that is true. It has got only one pier coming. Pile is converted to pier, so the redundancy is an issue. But we design monopile only when with a proper rock socketing, and after thorough investigation of the geotechnical condition. In Mumbai, Coastal Road project, and if those who have visited Mumbai Coastal Road or Mumbai specifically near the seashore, you will see lot of rock outcrop, and the rock is quite up. So in this particular case, for Mumbai Coastal Road project, there's the encasement of around 7 to 8 meter inside a very rock strata. So there's a special drilling technique which is adopted. There's a specialized dredge drilling company which those who have done this kind of work. So with that rock anchoring, the structural safety and redundancy issue is resolved.
Right. Also, in early contract involvement, how do you carry out competitive bidding? And is there any example?
Yeah, there are various kind of early contractor involvement contract in worldwide. There are guidelines related to that in NEC contract document. There is a feeling that competitive edge is a bit less when you compare to overall EPC contract bidding, normal EPC contract bidding. But because in this case you are hiring a contractor with a sort of lump sum fee during your design phase, and you are sort of finalizing your project cost and methods with his input into the plate, and that way your project cost and methods, your design methodology is much more firmed compared to a sort of EPC, normal EPC contract. But as I said, that it slightly less competitive compared to APC contract. But overall, if you compare the overall savings in the project, which is around 7% in cost and 10% in time, which is globally, that data shows that. So that way, ECI is getting quite popular because of this advantage.
Right. And the last question would be, what is bendable concrete as a new material?
Okay, bendable concrete is basically you are putting fibers inside the concrete, and your modulus of rupture for concrete or tensile capacity of concrete increases quite a lot. This is used in smaller structures where loads are less, but you can save considerable reinforcement quantity with this kind of material. When I was there in one conference in China, Hong Kong, there the Chinese universities, they are developing quite a good bendable concrete material which can be used for higher load situation as well. So so globally this is becoming popular, the bendable concrete.
Okay. On that note, we close this session. Thank you, Mr. Chattopadhyay, for a very detailed presentation and patiently answering all the questions as well. Thank you for joining us and for your time. Thank you so much once again.
I want to thank you, India Infrastructure, for giving me this opportunity, and thank you all the delegates for listening to me. Have a great day. Bye-bye.
We're ready for the next session, which is a Sri Lanka focused bridge construction project over the Kelani River, where we have Mrs. Darshika Jayasekara joining us. Before I begin the session, I'll just quickly introduce Mrs. Jayasekara. Mrs. Darshika Jayasekara is Director Planning at the Sri Lanka Road Development Authority and Acting Project Director at of the new bridge construction project over Kelani River under the Ministry of Roads and Highways and Road Development Authority. She has 25 years of experience as an engineer at the RDA. Previously, she has worked in the Highway Design Division as design engineer and project engineer for the Colombo Katanyuake Expressway project. Mrs. Jayasekara is a graduate of the University of Moratuwa with a BSc in Civil Engineering and a master's degree in highways and traffic engineering from the University of Moratuwa. Mrs. Jayasekara, we're ready for your presentation. So it's going to be 20 minutes of presentation followed by 5 to 10 minutes of Q&A with the delegates. Over to you, ma'am. You're on mute, ma'am. Yeah.
Yes. Can you hear me?
Yes, ma'am.
Yes. Can you hear me?
Yes, you're audible.
Okay. Thank you very much for giving the opportunity to share the experience about the bridge construction project over Kelani River. Okay, first of all, now this is my content of presentation, introduction of the project, New Kelani Bridge project, and steel bridge, steel box girder bridge section, and extra doors bridge, and approach PC box girder bridge, and construction techniques, best practices and their benefits and challenges faced, and the lesson learned. First of all, let me share the details of the project. Now, project name is New Kelani Bridge Project. Now, it is popular as the Golden Gate Kelani at Sri Lanka. Funded by JICA government and the government of Sri Lanka, and client is Ministry of Highways and Road Development Authority. Consultant, Oriental Consultant, Katahira, JB, and contractors JFE Mitsui Toda, JMT JB, and Sanken SMCC JB. Total cost is Japanese yen 1,035,020. Project duration is 4 commence in 2018, October 17th, and the completion 2021, November 25th. Now, first I will explain where the location. Now, this is the country Sri Lanka, and this is the Bandaranaike International Airport. Now, that will be directly connected to the Colombo-Katunaik Expressway. At the end of the Colombo-Katunaik Expressway, this project comes. Now, it will be like this. Now, this is the expressway network in Sri Lanka. And this is the Katunaik Expressway, Outer Circular Highway, Central Expressway. Now here proposed two highways. At the moment, these urban expressways are in construction. Now this project will be considered as a connecting expressway network connection project. And this is highly congested area. And this is the layout of this one. Now this will be connected to the another urban expressway to the Colombo port. This expressway will be connected to the another Battaramulla outer circular highway connection comes in this way. Now this is the project comes. Now here actually project consisting of the two types of construction. Now you can see the blue line is the, now here we name it as the package one, is steel bridge construction. Now here we are constructing the steel bridges, this stretch entire, and this section is we are constructing the concrete bridge sections. Now this is the steel bridge section that we have already constructed here. Now I will give you, now these are the components of steel bridge. Now here, this is the board piles and the pile cap will, and the steel pier will be connected using this anchor frame. And here steel pier, steel box girders, on top of that steel concrete composite slab, and the asphalt pavement comes as a composite pavement. Now, why we going for the steel structure? Because steel is quite expensive than the concrete, but there's a reason why we are going for the steel structure for this particular location. Because dead weight is reduced by 50%, resulting in the smaller foundations. Because the particular two roads congested in the 132 to 220 kV massive lines are there undergrounds. Therefore, we find very difficult to find the location for the excavation. And also here we are using the portal frame support multiple carriageways, but here we have to do the construction in the on top of the multiple carriageways. Therefore, we have to use the minimum number of temporary supports. And also here we have to use the small curvatures we are using. Therefore, steel box girder basically negotiate with the complicated road alignments. And steel box girders can be erected, lesser temporary supports. Maintain the existing traffic, minimizing impact to the existing traffic. And also here we are using steel concrete composite deck that can be completed without temporary formwork and propping to minimize the impact. Now I will show you the photographs of that one. Now if we go for the concrete structure, foundation would be very large. Therefore, here we are having underground 132 to 220 kV lines. Therefore, it will be create problem for us. And we always, as Mr. Chandragupta earlier presentation explained, we have to go for the accelerated construction method. That is why we are going for this one. And also here you can see now this is the multiple lanes of the construction. Now this is the very busiest road in Sri Lanka in Colombo city. On top of that one we have to carry out this construction, and here we are using only one prop here without disturbing to the existing traffic. And also here small curvatures here we have to use for this construction, therefore we went for the steel structure. And also if we are going for the concrete bridges, now we have to provide so many temporary supports. But with this heavy traffic, we can't do that one. Here we are using only one, and we can do the erection in the night within 2 hours. But we have to get ready for the 4 hours ahead and 4 hours after that. But anyway, this is the reason that we are going for the steel structures. And also on top of steel structures, here we are using the steel composite decks. Now this is the steel bottom, steel composite formwork deck slab we are using here. Now this is for the high durability and shorter construction period because due to less reinforcement arrangement, formworks and the scaffolding, and better working condition on site, we can do it safely. And no temporary formwork required, minimize disturbance to the existing traffic, no fear of leak, wet concrete and cement melt to the existing high traffic roads, enhance safety during the construction. Now here, and also now this load will transmit to the webs, and also this is lightweight, live load due to steel and concrete composite deck slab transmit live load due to vehicle traffic through combined action of steel plates and ribs with concrete, and therefore slab thickness is thinner than the RC slabs and PC slabs. Therefore, dead load is reduced. As a result of that one, foundation size also get reduced. It has high durability and long life compared to the RC slabs. And since no formwork is required, therefore, actually, this can be site construction period can be short. Now, and also here we are using the 5-coat system. Now here for the long life durability paint system, epoxy coat specified for coating of steel members in order to reduce the life cycle, maintain cost and ensure long-term protection against corrosion. 5-pane system were specified depending on location, member and the exposure conditions. First coating we use as a primer. Inorganic rich paint provides sacrificial protection. Second coating mist coat, formulated epoxy coat, sealed to eliminate air holes. Third coating primer 2 epoxy resin and preparatory coat before painting, protection of the material, preventing infiltration, salt, lead, air and water. And also fourth coating, undercoating, epoxy resin coating for fluorescent resin, ensure addition of top coat primer. And also fifth coating also, top coating, fluorescent resin top coat, luster cooling, coloring and preventing infiltration, salt laden advice, and protect from the UV radiation also. Now these are the coating system that we are adapting for this steel structure. And also now, as we said, now this is very heavy. You can see the heavy traffic over here. Therefore, we have to use essential to minimum impact to the traffic flow. And also here, that is why we are going for, although these are PC box girders, when compared to the cost is high, but if we go for the If we go for the concrete, I think due to the huge duration and impact to the traffic, now it will be cost more. Therefore, we went for the steel structures like this. And also here steel bridges can be used. Now relatively we can use for the longer spans. Range is 40 to 80 meters. Now here one section straight portion longer span is 80 meters. Therefore fewer piers are required for this one. And also now these are the now we will go for the steel. What are the construction technique we use now? I told you we use the steel box girder, steel portal frame, SSCD panels, now steel, concrete, composite deck, corrosion protection painting, and waterproofing. And also in addition to that one, here we have used the SBHS due to high yield strength and the lower preheating temperature for welding. And use of torque shear high strength balls for friction grip splice joints due to ease of preloading required tension loads, and fabrication of steel members simultaneously conducted multiple factories to expedite the production. Now in 2009 Japan Society Civil Engineer published this design as the fabrication guide for SBHS. SBHS was introduced by the specification for highway bridges as the new material for steel bridges in 2014. Now, this is characterized by high yield strength and high fracture toughness, lower preheating temperatures for welding. Now, ensure the better structural performance of steel bridges and allows reduction of weight of steel structures, and lower preheating temperatures for welding ensure lower fabrication cost. And also now as I told you, SPHS is characterized by high yield strength, high fracture toughness. Now because now if we go for the other steels, SM400, SM490, minimum tensile strength would be the 400 megapascals, and here 490, and specified minimum yield strength is 235, 355. But if we are going for the SBHS 500, minimum tensile strength is 570 and the minimum specified strength is 500. Therefore, I think here we are using this type of material for this one. And also here we have used the torque shear strength balls. Here we are calling this the tension control balls for fastening the material for the joints, splice joints. Now these are the TCBs we are using. Now this, and also here we have done the construction. All the fabrication has been carried out in the some other countries, because approximately total quantity 21,300 tons steel piers, steel box girders, SCCD panels was required to be fabricated within 1.5 years in consideration of overall project period. Therefore, in order to ensure the timely production, fabrication was undertaken multiple factories in Japan, Myanmar, Thailand, and Vietnam. All fabrication work was directly supervised by contractor fabrication engineers, and also factory due diligence inspections were conducted jointly client engineer and the contractors. Finally, all the production, all the materials imported to the Sri Lanka. Now, if you are moving to the extra dose bridge section, now here I have talked about the steel bridges. Now, when we are moving to the concrete bridge section, main bridge constructed in that section is the extra dose bridge. Now, this is the 6-lane bridges. 6-lane total deck width is 30.4, double plane stay cables here. Now, this is the cross section of this one, extra dose bridge. Basically, I think earlier presentation also explained about the extra dose bridge, but here we have used same bridge for this project, because here inner span is 180 meters and outer Outer length is 100 meters. Now, entire extradose bridge length is 380, midspan is 180, and outer span, side span is 100 meters. Overall width is 30.4. Now, here this consists of the 3 cells, PC box girders, and U-shaped pylons, and pylon height would be from the deck to top is 23 meters. And also non-grout anchor box system first and stay cable system adapted. Now, if we are going for the why we are going for the extradose bridge, now if we are going for the girder bridge, and extradose bridge is the intermediate situation above the girder bridge and the cable stay bridge. Basically, earlier also presentation said up to 50 to 150 meters, but here our span is 180, but basically that can be recommend 100 meters to 200 meter length bridge. But this is quite economical than these two bridge. Now, if we go for that one application, as I told, 100 to 200 extradose. If you go for the cable stay, it can go 300 to 500 meters. But here, vertical load sharing ratio of live load is 10% to 20%. But if we go for the stay cable, that would be the 80% to 100. The main girder bears the vertical loads. The stay cable bears the vertical load. Allowable stress table is 0.6 ultimate strength, and here ultimate strength is 0.4, like that. But if we go for the case study for the Kelani bridge, if we are going for the girder bridge, girder height would be the 12 to 10, 15, and this is very heavy. We can go for the large foundations. But if we go for the stay cable, girder height would be 2 to 2.5, but pylon height would be the 36 meters and need many stay cables too, because load carrying capacity still is very high. But if we go for the extradose bridge, girder height would be the 6 meter to 5.15. Pylon height would be the 22.5 from the deck, and this is quite economical than these two. Therefore, we went for the extradose bridge, economical. And if we go for the design flow chart, initially we will have to select what is the bridge type, and box girder bridge or extradose. Now that we have already selected. Now the planning design conditions, pier locations, girder heights, material design and criteria. Here we have to do the need to do the trial calculation. We have to do the girder design, stay cable design, pylon design, and foundation design. In addition to that one, accessories like bearing and expansion joint and etc. But if we go for these are the two control points, out of which we use these two control points. Here we have selected the midspan, and this is the control point for the side. And here finally decided go to the extradose bridge, considering the economical conditions and the construction easy accelerated construction method earlier presentation stated right there. And these are the materials used: concrete cube strength, pylon girder 50 MPa, pier pile cap piles 40 and grade 40, and the Young's modulus pylon 34,000 MPa, girder 39,100 MPa, pile 31,000 MPa. Yield strength 460 MPa, pre-stressing strands we use yield stress 1,600, tensile strength 1,850, Young's modulus 195,000, and unit weight of area should be like this. Okay, we design standard, we use the design manuals, Road Development Authority 1997 and BS 5400 latest version standards. Vehicle load HA loading is considered like this, HV loading and wind load is 33.5 and temperature is like that. And also here we have considered the various load combination, traffic load and wind loading without traffic, wind loading with traffic, temperature leading loading and secondary live loading, and likewise. Similarly, we have used the finite element method for novel frame. Now here these are the key points, pier locations and the end of the abutments. Now here in that model, we basically consider the model 11 pylon with the pier segment, pylon P20, P21 pier segments without temporary fixing like this. And after that, we went to the model number 54, bridge during construction installation, the first stake cable in the bridge. And after that, bridge model 164 during last stake installation of last stake cable like this. And if we go for the model 300 after entire completion of the project bridge. Now these are the stress calculations like this. Now these are the stress calculations now during the construction stage. Stresses for girder are within the tolerance, detailed design and the contractors. Now this is the detailed design. Now this is the contractors stress results during construction. Yes, now all these design details, I'm not going to go that one. Now here we are going to move into the construction technique that we are using for this one. First, as previous presentation stated, that we have to go for the accelerated construction techniques. Now this is balanced cantilever erection method. Here we have used an anchor box type, non-ground saddle structures and geometric control we carried out. Now this is the construction now on top of the deck concrete. Now this is the pier head construction. Initially we have to construct this one. After that, in middle part up to this point, number 2, using the balanced cantilever method. After that, we have to construct the end span. After that, we have to do the side closure. Finally, we are doing the center closure. Now here we are using the foam traveler cantilever section. Now I will show you the due to the small video of this one Now here box girder segments were 4.5 in length. Box girder depth varies 5.6 to 3.3 at the center medium spans. Due to self-supporting cantilever erection method, underlying temporary supports are not required because actually here this therefore no disturbances or no any work in the middle of the river. Now just now this is the method foam travel animation. You can see this one. Here we have to form traveler to move forward. After that, we have to construct the diaphragm wall over there. And now, after that, we have to do the stressing at the stake cable. Now here stake cable bearings, and now here actually this girder supported by pot bearings at the pier location and 64,000 kilonewton for inner and the 6,400 kilonewton for inner and 6,000 kilonewton for the outer bearing, longitudinally fixed at one pylon only. And epoxy coated field tendons we used, basically 37 tendons in each cable and 24 close to the tower we use the 24 cables. And here we are using the fan configuration. Now there are 3 type of configurations for stake cable anchorage: saddle type anchor, and likewise, because why we are going for the saddle type, in case if any strand damage without disturbing this one, we can connect it from here. Now stake cable, now here we call the stake cable anchorage. Now here, like this. Now when it is, now these are the anchor box saddle structure. Initially when we are constructing, we are fixing this saddle first, after that connecting this one, and stressing has been carried out at the later.
Thank you, ma'am. Please wrap it up in the next 1 more minute.
Sorry?
I'm saying just next 1 or 2 more minutes for the presentation.
Okay, okay. Now this is the okay. Now I will rush through. Here we have used in the after that what we call the we have done waterproofing using on top of build for the for more duration. And here we have used the polymer modified this one, and we carried out the geometric control when we are doing the construction. And here we are using for the cooling pipe arrangement, and when we are doing the when we do the mass concrete, because we have to maintain the core concrete 20, and this one is we have to follow the specifications. Now these are the arrangement that we carried out. And also here we have used the architectural intelligent lighting system. Therefore this bridge has been called as a theme bridge. It is not general light, it is actually installed system like the architectural intelligent lighting system. Now this is the second theme lighting bridge in South Asia. Now when the lightings are in the night, we can see like this. Now here we have used the special landscaping with the drip irrigation system. And also here we have encountered so many because existing underground services are very high, therefore very difficult to do the construction with the heavy traffic in this area. And also there are so many houses to be relocated, so many buildings to be relocated. But anyway, we've handled very carefully in 2013 onwards, and we could complete it without any claims, and we could complete it very successfully. And also here we have carried out the EIA resettlement action plan completed in advance finding, and we have done follow all the procedures very correctly, and therefore as a result of this one, actually no delays, not only the delay caused due to the COVID situation. And we carried out throughout within 4 years we could successful completion. I can show this video, this bridge, and I can stop it. Thank you. Thank you very much.
So we're ready to take some questions from the delegates. We have a couple of questions for you. One of the delegate wants to know, can you explain more on anchor frame used in the project and connectivity details with the foundation?
Actually, anchor frames we have used, especially it is huge fun. Because bottom pile cap is constructing in the concrete, and the top is the portal frame, and anchor frame is connecting to the pile cap using I will show you the yes, now this is the anchor frame. Here pile cap is connecting this anchor frame to the steel pier. Now with that one, actually this is specially fabricated in Sri Lanka. Now materials comes from the Japan and fabricated in Sri Lanka, and from this one it is connected to this one. This is concrete pile cap, the concrete pile cap, and this is the steel pier.
Okay. Also, why hasn't been adopted? Is one of
Sorry,
why hasn't weather steel been adopted?
with the steel we cannot go for this type of structure, and still it is under the research stage, so far not yet utilized. Now therefore we can't go for the weather steel for this type of structure. If we can for the special isolated bridge, I think it is possible, but this is I think it is not suitable for this type of location.
Also, the construction period is 4 years, and you use steel structures to reduce the construction time. But the project completion took 8 years, which increased the cost. So, any specific reason for the delay?
I can't hear you. Please repeat again.
Yeah, the question is that the construction period is 4 years, and you use steel structures to reduce the construction time. But project completion
Yes.
took 8 years, which increased the cost considerably. So, any specific reason for the delay?
Specific reason is one is the COVID situation, and here steel erection can be allowed only in the midnight 2 hours because due to very heavy traffic in this area. Normally we are closing the road for the traffic is around 10 o'clock, and starting the erection work after arranging all the machineries around midnight 12 o'clock, and we have to do the erection in the another 2 hours time. After that again open the traffic for the another morning by 5 o'clock, and this is very heavy congested city and congested location. Therefore we found very difficult when we are doing the erection also.
Okay.
But anyway, if we are going for the concrete structures, we won't be able to complete during this period.
Right. For bridge deck waterproofing, what approach has been followed?
Here we have used the what we call yes, silicate base penetration type one we have used. Silicate base surface penetration type we have used for the waterproofing. Now that actually penetrates and the concrete and reacts with the free calcium and water to form the calcium silicate gel. Here, like now if there is any cracks here, that silicate gel and penetrate and it will seal this porosity. Therefore, this is the method we have. There are so many methods, but with the consultant, we analyzed so many times. We had so many discussions about when we are selecting this one. Finally, we decided to, now we will have to think about the economic situation also, economically viable. And therefore, we went for the silicate-based surface penetration type waterproofing, and it penetrates and reacts with the calcium, and this gel formation, after that this porosity can be protected. And from this one, actually we can reduces the life cycle cost by extending life of the bridge deck. But especially we have to do it because here we are using the SSCD panels. If the water penetrate into the SSCD panels, it is not good for the steel structure. Therefore, we have to do a good penetration method, waterproofing method for this one.
Right. Also, one of the delegates is asking, didn't you feel the need to provide a breakdown lane? Because in the case study, couldn't see any breakdown lane. So,
Sorry?
Don't you feel it was necessary to provide a breakdown lane?
Breakdown?
Lane. That's one of the questions from the delegates. So, if
breakdown of the design. I can't hear.
Can you hear me now?
Yes, now I can hear you.
The delegate is asking, going through the case study, couldn't see the breakdown lane. So don't you feel
breakdown?
So don't you
breakdown
lane
link?
LANE lane.
Yes, we can not link now here. Actually, the case study we have prepared, our design reports are there, but we have not yet published in the website. Design details and the report, detailed design is there, but we haven't published in the web.
Okay.
But if in future, after now this is end of the construction, so we can publish that one later. No.
Okay. What type of bearings and expansion joints have been used in the extra dosed bridges?
Now here pot bearing we have used. Here we have used the pot bearing at the extra dose bridge. Now this is one end is fixed and other one is movable.
Okay. Also, the question is, in the last video, bridge next to new bridge is having intermediate piers. So why piers are not considered for new bridge?
Yes, actually now we will have to go for the, now if we are going for the intermediate piers, the construction duration will be very large, and also construction is very difficult. But here with lesser now earlier presentation also we are moving to the fast construction technique, accelerated bridge construction. Now this is one of the technique we used for the accelerated bridge construction technique, because if we are going for the pier construction, it is very difficult construction because this water level is very high. During the flood situation, very difficult to construct. Now there are a lot of pros and cons. But even though if we think now the cost can be reduced, but I don't think when we compare to the overall, it may not economical.
All right. I think the delegate has verified his question regarding the breakdown lane. He's saying that at the cross section, basically there's no breakdown lane. So
This one. Okay. If anybody wants, we can email and we can share that one.
So Mr.
Okay.
Gujal can drop a mail to Mrs. Jayasekara and she can verify it.
Okay.
All right, with that, we'll bring the session to a close. Thank you, ma'am, for your time, and thank you for the detailed presentation. Thank you for joining us once again.
Thank you very much for giving opportunity to share our experience. Sometimes 20 minutes is not enough to share all these things, but anyway, I think some sort of experience I could share with you. Thank you very much and have a nice day. Okay.
Thank you, ma'am. So with this, we have a short 20 minutes break, and we would be reconvening at 12:40, which is as per Indian time, and 3:10 as per Singapore time. So request you all to please join back on time. So it's going to be 3:10 Singapore time and 12:40 Indian time. Welcome back, everyone, to the second edition of Bridge Construction in Asia. For the next session, we have with us Mr. Sitarama Sagi, Managing Director, IDDC Engineers. The session would be on bridge repair and rehabilitation. Before we start the session, I'll just introduce Mr. Sagi. Mr. Sitarama Raju Sagi is Managing Director at IDDC Engineers Private Limited. He has over 30 years of experience in health study and non-destructive testing, asset management systems for bridges and buildings, pile testing, architectural and structural design, etc. Mr. Sagi is a civil engineer with a master's degree from Osmania University, Hyderabad. Mr. Sagi, we are ready for your session. You could, I think you're facing some issues, so you could present without your video, without switching on your video. Over to you, sir. You're on mute.
Yeah. Good afternoon to all the participants, and welcome to this presentation on bridge management and maintenance and safety of the topic given to us. There are three components in that. Just 1 second. Yeah. Today we are covering the topics on which play an important role for an efficient and effective bridge asset management. All the topics, emerging solutions of bridge repairs, role and technology in bridge rehabilitation and management, new innovations and advancement for bridge maintenance and safety would be a component of bridge asset management system. So ensuring that updated technologies are implemented for the repairs, restoration of bridges and safety is ensured. So before we go into the asset management system, briefly, we would like to share with you that IDDC Engineers are the developers and implementers of Indian Bridge Management System since 2015. And more than 172,000 bridges, culverts were part of the system that has been executed by us for a period of last 4 years, subsequently followed by a concessionaries component where the improved system has been implemented. So with the 7 years of improvements, improvements and research was a continuous process which has been happening. And we are trying to put all effort to improve the system. And as a brief background of what was done in 2015 is something which I would like to share in the form of a video. Address. Video is not interactive. Directly we play and share the screen. Are you able to see the video, Ishita?
No, sir, actually you are sharing the PowerPoint presentation on the share screen mode. You'll have to share the video on share screen.
It has a hyperlink.
No, the video is not playing at our end, sir.
We can only see the picture right now, sir.
New share. ಇದನ್ನ?
Yes, sir, it's visible now.
There's no audio. Is there any audio as well? Because we can't hear anything.
The video is.
The video
Yes, sir, we can hear it now.
Yeah. But link up. Okay. So this is the background of what has been done earlier in 2015 to 2018 and subsequently improved. The improved system based on the needs of the custodians and users. We have been consistently improving the system wherein 100% digitization of the inspection has been one part of the inclusion. And based on the symptom-based, we have shifted from symptom-based distress identification and intervention. The approach has been internationally what has been the accepted approach of the cause-based distress based on European code EN 1504. The developed one with the current version is something I would like to share in my video right now. Sure. So based on the requirement of the custodians, based on the distress levels, and based on the improvements in the system, we thought shifting from symptom-based to cause-based was the basis for improving the system. And in this exercise, some of the custodians wanted the non-structural components, including the railings, the carpeting, approaches, all components to be included. So that also has been made part of the system in the improved system so that user can have the total management of the maintenance of the total bridge, structural and non-structural components.
Sagi, the audio is not clear. Mr. Sagi, are you able to hear me?
Yeah.
The audio.
Are you able to?
I'm able to see the video, but the audio is not clear.
It is audible.
I think we could have your presentation itself because the voice is not clear of the video.
You are not able to hear the video?
No, no.
One
we can
second.
see the video, but we can't hear it. So why don't we have your presentation up and
Yeah. Yeah, go back. Presentation. Yeah, the audio was not clearly, I mean, clarity was not there.
yeah, there was no clarity. It was very less and it was not clear basically.
Okay. So the improvements, what partly you could see, that those are the improvements that have been made to meet the current day requirement and to improve the system for the performance in all aspects of the structural and non-structural components were also included, because the users spend ultimately in a year, they spend about 70% of the cost in the maintenance goes for the non-structural component. Only 30% they spend on the structural component. So what they said is integrating the maintenance into the bridge management system is the requirement what they wanted, which has been facilitated and improved and being operated right now for the last 3 years. So coming to the emerging technologies for the strengthening and repairs. Some of the strengthening and repair systems were also discussed earlier in earlier sessions. The most important component of this strengthening is EFRP and FRP, which has facilitated practically to ensure that the bridges are strengthened for enhancing their balance service life. For the regular bridges, even the post-tension systems also are being taken up and executed, and wherein this is able to provide, minimize the post-tensioning component, minimize the effort of cutting across the girder to fix the brackets and do the post-tensioning system. Directly application on the surface with a post-tension carbo door is something which has been effectively been able to provide the solution, and also in the process increase the flexural shear axial strengthening of the structure, apart from providing the seismic resistance also to the structures. Practically all these things have been happening in the last 3-4 years. So based on that, this is the one aspect which provides the technology for support of the ensuring the safety of the bridges and strengthening of bridges. Load bearing capacity of the structures for the static and dynamic loading. Load testing post strengthening can be done, even monitored. So coming to the role of the technology for the information technology is the key, wherein the data collection software loaded on a tablet is able to communicate with the server by transmitting the data for the inventory, condition survey, inspection, testing at various stages of the exercise of bridge inspection, condition survey and testing, because all of them will not be done at a time, one after the other. The modules are operative for first stage of inventory condition survey, then the inspection, then subsequently followed by testing, followed by uploading the repair and rehabilitation system, including the cost of that. And here, one major advantage is prioritization of the spending the money for repairing the bridges, because maintenance is something where the budget is very nominal across the globe. Construction, they provide the full funding for the execution of construction. But when it comes to the maintenance, only a small percentage is available for the users. So they have to judiciously use the fund for repairing the worst bridge to start with. And this prioritization based on the socio-economic criteria of the bridge is part of the system which has been developed, so that the end user can make a conscious decision of spending the money to ensure that they are rehabilitated and they are brought to safe level with the minimum cost within the timeline and the budget available. So this is another important component that has been inputted in the system. So coming over to the other structural health monitoring component, which are the innovations, I would like to share a small video. I hope this would be audible. Is it audible and clearly visible, ma'am?
It's visible, but the audio is not clear.
This technology has a cloud-based system. It is easily adapted to EMS-based systems.
Mr. Sagi, we have 7 minutes for your presentation, because we also have the Q&A.
Yes, yes. We are through. Okay. Apart from structural health monitoring, another important development is artificial intelligence. In developing countries, we don't have certified bridge inspectors who can assess the bridge condition and give the rating and ranking. It's either 1 to 0 to 5 or 0 to 9, whatever the basis that is being followed internationally. So for the custodians to make the job little easier, without a research on cause-based defect ranking approach for existing bridge structures based on AHP and fuzzy logic and TOPSIS, a research has been done. A paper has already been published in Structure and Infrastructure Engineering to ensure that a preliminary assessment of the bridge is done based on the symptoms visible or seen, even by a non-bridge expert. Once he inputs the data, the fuzzy analysis will categorize bridge based on the cause-based defect. 0 to 5 ranking is given, so that the intervention of the custodian or the user is possible, even if they don't have the bridge inspectors, certified bridge inspector to do the bridge inspection. So this is one topic which is being taken up and it is in progress. Using drones is another part which has been already started. Using the drones for condition rating and the distress mapping and evaluation of the bridge condition. The same drone data will be used in future for creating the 3D models of the bridges with distress plotting, which is in progress. Integrating bridge information module into the system is another development that is something which has been scheduled in to be taken up next year. So these are the other innovations and inputs that are being developed for implementation for ensuring the safety of bridges. Photonic technology for doing the condition vibration monitoring, where amplitude, velocity, and acceleration in time domain frequency are collected and analyzed for evaluating the bridge status. Similarly, vibrational effects detection analysis. The equipment is available, which is being implemented or operated at different places for doing the vibration and condition monitoring of the structures, pipes, foundation, and other structures also. So this would help in improving the evaluation of the bridge condition and rate them from the performance point of view. Deterioration modeling, risk analysis, service life, bridge service life analysis, load capacity of the bridge for clearances for overweight vehicles, because some of the bridges which are to be loaded with the ODC and overweight and over dimension vehicles, specific clearances are to be ascertained by inspecting the bridge again before giving the clearance. So this load capacity of the bridges evaluation in the faster means is something which is a need for ensuring the transportation of infrastructure heavyweight vehicles to reach the destination. So whatever, I would like to conclude with whatever the Prime Minister and the Minister for Ministry Transport and Highways has initiated or discussed about. This is not launched. Are you able to hear this clearly, ma'am?
So the audio is not clear, but we can see the video.
Volume. Should that is the thank you. So thank you all for the patient hearing of the improvements that are made in the asset management system of bridges. For any queries, I'm available to give the answers.
Thank you, Mr. Saki. We have 2-3 questions from the delegates as well. So the first question is whether is the developed software for IBMS, can the developed software for IBMS accommodate the outputs of structural health monitoring system online?
Can you repeat a little louder?
Yeah, so basically the question is, can the developed software for IBMS accommodate the outputs of a structural health monitoring system online?
Structural bridge monitoring system. Yeah, structural bridge monitoring system module with the structural health monitoring is also part of that which is going to be integrated in future. We are doing the structural health monitoring for bridge structures right now. Independent of this, the data input is being given, but that is another module which is in development. Structural health monitoring will be integrated probably in the next 1 year.
All right. Also, one of the delegates says, by seeing various bridge photos, DL and LL is the only big challenge, leave alone seismic or durability performance. So what is the government response for repair of those bridges?
Yeah, the data has been shared with all the custodians like NHAA, NHIDCL, state, National Highway Bridge Engineers, border road organizations, and all of them have initiated the next level of detailed inspection of the same bridge for repair point of view. And the repairs have been taken up at various levels by the custodians based on the information that has been shared with them.
All right.
Here I would like to add that has it been done everywhere? I can't answer that. It has been done. To what extent, I don't have the track of that. But it has been initiated and it has been done. Please, next.
Okay. So what is the general strength of the concrete available for distressed bridges in general?
General strength
of the concrete available for distressed bridges?
That varies. That has to be inspected and tested. The strength has to be evaluated. So the strength as constructed, if it was M30 or M30, the current strength, if it is M20 or M25. So there is a loss of the strength in the concrete, and we find that such cases. But loss of strength alone is not the component to define the overall bridge condition. It is the level of corrosion in the reinforcement, and ultimately, if it is an old bridge, what is the load capacity of the bridge? That will be tested.
Sure.
So based on that, we will be able to evaluate and tell the strength is one component that contributes to the evaluation. Okay.
Sure. So there's one last question for you. Is it advisable to use FRP in repair of road bridges that are located in coastal areas? And if yes, then what are the measures to be put in place to ensure that FRP is not compromised?
The FRP in coastal area where post repairs, yes, it can be done. It will add as an additional protective if it is a FRP wrapping. It will be a added protective layer from chloride ingress, because of chloride ingress is the major contributor for the distress in bridges close to the coast. Yes. After proper treatment, yes, it can be done.
Okay. All right. On that note, we'll close the session. Thank you, Mr. Sagi, for your time and for the detailed presentation.
Yeah.
I'm sure all the delegates benefited from the presentation. You could, if possible, you could share the video with us and we could share it with the delegates.
Yes, we'll do that. And
Thank
sorry for not being able to be better prepared for the presentation. Some issues for not be able to show everything what I wanted. Once again, thank you all for the patient hearing.
Thank you. Thank you once again, Mr. Sagi. We're ready for the next session, which would be moderated by my colleague Akanksha. Over to you, Akanksha.
Thank you, Ishita. We are now ready for the next session for the day, which is on bridge construction experience, challenges, and key learnings. And we will be hearing from Mr. C. Sankaralingam, who is VP and Head Special Projects at L&T Construction. Mr. Sankaralingam is here with us already. Good afternoon, sir.
Yeah, good afternoon.
Sir, I will just take about 30-40 seconds to introduce you to our audience here today, and then you can go ahead with your presentation.
Okay.
So this is for all our delegates. As I mentioned, Mr. Sankaralingam is the VP and Head of Special Projects at L&T Construction. He comes with 40 years of experience in civil and structural engineering, including project development, design, and construction. He joined L&T ECC in the year 1980 and has since successfully completed 26 infra projects. He has worked as resident engineer in Malaysia, as construction manager in Konkan Railways, task force leader of the Hyderabad Metro Rail project, VP and task force leader of the Vizag project, and many such other projects. He is currently STECO chairman of the Mumbai-Vadodara Expressway, Mumbai-Nagpur Expressway, Dwarka Expressway Package 3, Dwarka Expressway Package 4. He is also board member of Heavy Civil Infrastructure, IC, L&T Construction, chairman of Supervisory Board, Larsen & Toubro and SUCG China, which is a joint venture for CC05 and CC27 Delhi Metro. Mr. Sankaralingam is a civil engineer and he also holds a master's degree from Madras University. Welcome, sir.
Yeah, thank you.
All right. So my colleague Ansi is sharing your presentation. Sir, I would just request you to please let her know when she should move to the next slide.
Sure.
Yeah.
Okay.
Please go ahead.
Right. So you can go to the next one. This is an view, right? Currently, I just wanted to touch upon the following things. One is the bridge construction. What is the latest technology is going on? Particularly in segmental construction, there are two types, which most of the people are aware of it. One is the long line, other one is the short line. And also in erections, normally we do it within a span by span as well as balanced cantilever. The third one is the full span construction, which is the currently going on in the bullet train, in which the casting as well as the erection. The next point is benefit of the latest construction techniques. What is the benefits, which we just touch upon few points. And then later on, key challenges with this latest method. What are the issues which we have? And last but not least, the lessons learned from the current and then previous projects. Yeah, go to next. Yeah, now the current techniques, in these segmental constructions, which, the precasting, which is being carried out in a separate precast yard, and then transported to the site locations using the launching girder, we start erecting either the launching girder or bridge builder, both span by span as well as the balanced cantilever methods. The segment type or reduce the cost, particularly, when you do that separately in a parallel activities. So one is the time will be reduced. You do that, the site-based activities of foundations, piling, all those things, you do it at site. Whereas the segments will be cast in a different locations. You don't require to do that within the ROW, which is normally, the employer will get you exactly what is it required. So get some land and then, do that entire precasting and then shift it to the site and then erect it using the launching girder. Other one is the doing all these things instead of in situ construction. In situ, you know, there's a lot of things involved, particularly supporting, staging, and doing concreting, which will give a lot of, you know, issues regarding the environment as well as the traffic management. So this way you will be able to get benefit out of the, you know, the precasting. You do it in the independently. Yeah, next. Now there are two methods which I was talking about. The first one is the long line method in the segment casting, which, you know, people may be aware of it. I just touch upon a few highlight about the points. The long line bed where the diaphragm segment, the first and then the last in a span, which you do it in a separately, independently, in which, you know, with the correct line and level, everything with the reinforcement, sheathing, profiling, end anchorages, all those things, and do it everything, and then bring it to the precast, you know, the long line bed as a end positions, and start casting as a match casting to the next segments. You just see the next pictures. Next. So this is the short line mode, or rather the pier head segments, which you do it independently in a short line methods. And then next, you move it to that, you know, what you see the front. First one is the short line methods, you know, the mold where being done with the diaphragm segments. And then when you shift it to that, you know, the long line bed where you see the far side, the first segment is done, and then the next consequent segment will be cast. So that way you will do it in the long line bed, you know, with the long line methods, you know, one full span. If it is 35 meters, 40, 45 meters, you do it in the same bed. Where this long line bed will be, you know, used to be better in straight line where you don't have much curvature. If there is a small curvature, still it is manageable. But if it is a long, short, sharp curvature, then that will be very difficult to align adjustment. So you go with a straight line, little long curvatures, you can use the long line method. Next. So this shows the sequence of how you do the, you know, whatever the casting be done. First, this short line mold, and then there will be an outer form will be there. Then the reinforcement gauge will be all be done with that. After you place it, then the inner mold will be fitted. Next, then the bulkhead will be fitted on the other sides. Then you do the concreting. So this is just one cycle of what activities are there. Yeah, next. So this is what you can see, that whatever I explained, that left side and right side where you done that segments, adjacent segment done, then the inner form will be taken out, then another segment will be done with the outer shutter will be done. Here the important thing is the bottom mold of full span will be kept. On sides, you can have about maximum 2 or 3. Inner, depending on the inside thickness, web thickness, if there is changes, then you require additional numbers. And a transfer from bigger size, you know, the thickness of changes from that, you know, some whatever the 400 to 300, then there is a transfer, there will be additional inner will be required. Otherwise, it will be maximum 2 or 3 inner is good enough. You can do it one thing. And also this long line method, it is always cheaper because not much hydraulics or movement of trolley or anything. It's only, you know, operating through the, you know, sides as well as the side shutters as well as inner shutters, which will be always have a fixed dimension. You don't have much more complicated of things compared with the short line mode. Next. So this, the short line mode, where how it is being operated, where you have a fixed bulkhead, and then you allow about bottom trolley of maximum 2, because you do one casting and move to that other positions, then you bring it to that in between, again you do the one casting. So this particular one where you do that, which if you have a more curvature, you know, sharper curvature, this mold can be able to rotate, you can be able to, you know, turn it, all you can be able to do it with this kind of short line mold. And also the accuracy also you can get it better. When the speed is more, suppose in a one day, one casting, if you do that, yes, this will be definitely will be more advantage. We can be able to produce much more segments with one short line mode. Bit expensive, but the desired report, you know, the result you may get it by doing this kind of short line mode. There are many agencies there in India, they can able to produce this kind of mode. Yeah, next. So what you can see the short line mode, where the segment has been done, where you can see the front side, whatever the inner mold, rather, in the inner shutter, which will be pulled out of it. Other side, you will have the fixed bulkhead. So the segment, after it is casting, it is moved to the next, just adjacent to that, the side of it. Then you take the same bottom bed for that, put the side shutters, you do the casting against the first casting is being done. Next. So this similar same sequence. So this is what you see, that the bottom bed, then the sides, then there is a reinforcement gauge, bring it to the place. Then you do that with the inner formwork. Then what you put the side shutters, bulkhead, then you do the concreting. So the short line will be, if you can, entire operation will be done within about 8 to 12 hours. So then you produce it within 12 hours, you wait for that, the strength to achieve, then de-shutter and take out the segment and start producing the next day another segments. So one day, once, segments, which can be able to produce by this kind of things. Where you require little more skilled people, and reinforcement will be done in parallelly, and shutter cleaning, everything done parallelly. So that will go as like in a factory productions. Yeah, next. So what you can see that, the stack pile of the entire segment which is being done. Of course, this is a long line bed. It's not a short line, because this particular bridge which is having a complete straight line. Yeah, next. Now the erections, just go back. Yeah, just hang on. Basically, this kind of short, the span by span erections, it is maximum you can go up to 60 meters. Anything more than 60 meters, the simply supported or maybe a continuous, which will have a more impact on the permanent quantities. So up to 60 meter, people can prefer within a span by span erections. So this launcher or lunging girder have a front support, middle support, and rear support. Of course, one ancillary will be there in between. You may require some counterweight or not, depending on the type of the loading is concerned. So you have a top, whatever you see that on the front side, which is all the trolley, which can be able to, which have a McAlloy bar hanging, and then this will have able to lift it and then hold it the position at the top. Yeah, you can click next. Yeah. So the first one is you lift the right hand side of the diaphragm segments. Next. And move it back to the top of the pier. Next. So the next segments will be lifted. Next. So you can attach with that. Rather, it will be able to first be able to do that. Now you can click maybe 5-6 times. So each segment will be lifted. After it will be done 50%, then the diaphragm segment for the left hand side will go. Next. Yeah, this will be the other side of it. So like that, you can lift it one by one. Why we have a small, just go back one slide. You require about, doing for gluing between the two segments, you require about 200 to 300 mm gap. But if you really see that in a 60-meter span, you will not have much gap at the pier locations. So that is the reason we have a provision for lift one segments or a couple of segments on the top. So have a more gap between the segments. So we have produced that. So after the pier head segments, then the next segments will be glued and then attached with the stressing arrangements, temporary stressing, so that skews out the entire glue and make sure that will be done. And also you have protected the stressing cables. The glue should not go on and obstruct it. So that is all provision will be made into the things. Next. So after you've done the entire things gluing, then thread the cable for pre-stressing and partially, next you can click. So you have maybe about 15-16 cable will be there, but you don't require all the 15-16 cables, because the reason is you require about 50% to 60% only for self load of the deck. The things will be required to be carried. So that point of time, you have to release the entire hanger load, the vertical hangers, so that allow them to rest, because it's having a camber effect. It is, when you do the stressings, it will start going. That means the middle will start lifting. So if you continuously do that, you will have much more bow. So you have to lower it, allow them the dead load act, and then do the balance stressing. So that's why the stage 1A, number of cable will be 7 to 8, and 1B, you do that the balance cable stressing, so that it will be in a perfectly, it will have its a design camber. Then after that, you do the auto launching. So this way, the span by span, you can be able to do the erections. Next. So this is a photograph, what you are seeing, that some of the projects where it is being used. So you can see clearly the whatever the blue color is the trolley, and the red is the main launcher. Then we see the vertical hangers being held by the each segments. Basically, we'll have the pair of 2 hanger bar will be used for the hanging the segments. Next. So the next one is the more than 60 meters. The methodology will be changes using the balance cantilever systems. So it can go up to maximum 200 to 250 meters. So that entire, at the pier on left and right, you'll have about 125 meters there, up to 125 meters, you can be able to do the balance cantilever method. Of course, more than 90 to 100 meters, you have to go by an extra dosed cable or maybe stay cable, you have to use it. So this cases, whatever we have been talking about is only the erection for the up to 90 meters or 100 meters. So the pier table has to be cast at the pier locations. That means in order to erect that your balance cantilever, rather, the derrick, whatever the gantry, you need a base. For that, on top of the pier, you have to have a pier table. That means the pier head, you will do the casting, which will be normally either in situ. You can do with precast also, but most of the people prefer to have an in situ, so that you put a staging or you put a bracket and do that in situ constructions, and then receive the LG, which will be on top of it, on pair of left side and right side, 2 gantry crane will be placed. Next. So after you place it, then you will be start bringing the 1 by 1 segments, lift it, and then same way you do that first dry matching, check the geometry, everything, whether it is all right, whether dipping means, then we have to take care of with some shims. If it is top, depending on the shims will be used for that, vertical lifting or horizontal, the lowering or plan shifting also, you can be able to adjust that, so that you will get that correct profiling as well as, the geometry coordinates. Then after that, you do the stressing for the launch tunnel. Normally we'll have a pair of cable will be there doing that. But not only that, when you apply the glue and then stressing, you require temporary stressing also, you have to apply, you have to do that. After that, the permanent cable stressing will be carried out. Then the next pair of segment will be start lifting. You require a platform in the front of the, the launching gantry, or you call them, the bridge gantry, so that the hydraulics, jacks, people working for the gluing, everything you require to do that. Yeah, next. So this, what we have been showing in a, some kind of a schematic one, using the big launching gantry, similar to that span by span, but methodology of erection will be balance cantilever at PN, which is where you can see the couple of photos, slides will be coming one after the other, how this will be start erecting. So bring the segments, click next, and lower it, and then rotate. Then you attach to the left side, right side. After that, you do the first, normally with the in situ, you need to do stitch because it's not match cast surface. So you have to have a 200 mm stitches depending on designers, 100 to 200 mm stitches. Then next, you start do the precasting 1 by 1, erection of, those cables. So that way it will progressing. Maybe in between also you can do 1 more stitches. Maybe it depends on the geometry control required. Yeah, next. So what you are seeing is the bridge builder, not the big launcher. It is a bracket kind of gantry, which will be about weighing about 60 to 75 tons maximum. Have one segment can be lifted, including one platform. The anchorage, everything will be done the previous segments with the Macaulay bar. You have to hold it. And then a platform will be hung in the front, which will be used for your stretching of the cables. All those purposes will be used. So this way, when water, everything, either the water mode will be done, barges, you can take it, you can see the left-hand side, the barges, it's carrying the segments. Right-hand side, it may be the land, means you can use the, from trailer, you can lift the whole thing by directly from the top of the, from the bracket or the bridge gantry with lifting systems. Next. So this is another project where you can see the stay cables, because this span is 125 meters or 150 meters. So we have used these extra dose cable stay for 6 or 7 cables, so that after about 7 or 8 segments, then you start stay cable will be able to erect it. So that way it will be progressing. So the important point here is the vertical alignment as well as the plan arrangement, because this segment is as much as about more than about 30 meters width. So you have a plan dimension also, you have to be carefully monitored, so that I think you should not have about any bow effect or anything. Next. This is what the progressing almost the middle, where this is another project where it is much more cantilever, more than 250 meter spans. That is where we used little longer with the stay cable and all. Next. I think this is a Durgam Cheru in Hyderabad. So the middle closure is going on with the same bridge builder. Next. This after completion of that, this all the closure, everything, finish the entire span. Next, come into that, the full span methods. This is the one of the fast, the technologies being followed in India for the high speed rail. So there, I think, we can go for a full span casting. And the problem here is, how do you handle that full span? Because it's weighing about more than 900 tons. Normal segment, what we're talking about, the segmental bridges, it's about 75 tons, maximum say 125 tons, 130. So it's manageable with the gantry crane or crane. Whereas if you're talking about 900 tons or 1000 tons, where the length also it's more than 40 meters or 35 meters. It's not easy by any crane or anything. So you require different handling systems. So we call them as a straddle carrier, which can be able to lift the entire spans and then store it in a place. After that, we will be able to use it with the transportation. Also, special transporter will be used for transporting this kind of vehicle on top of the deck, erected spans. So we'll just go through that. So these are all custom made. You can't have a readily available anywhere. You have to order maybe about 5 to 6 months earlier or even 1 year. Then only you may get all those things. So this just we explained that how the casting being done, how the erection is being done. Next. So this is the casting, a full span. How to do the casting? The top left is a bottom trolley, bottom the grillage. Then you have a bottom shutters. The right and the top right, which is shows the outer shutters, and then yellow color it is the for inner shutter to travel within a support arrangements kept in the the whole frame, and then the bottommost bottom on the right side where you see along with the yellow color you have the inner shutter will be fitted. The bottom middle, which is shows that the inner form goes inside. So then the top left, the bottom left, where you see this segment comes out. So schematic one, how this is being shown with what are the components and how this is being done. Everything hydraulics, even this inner form will be collapsed with the hydraulics, with completely mechanized with all automations, and outer shutter also with hydraulics, it will be open up. And the segment after casting, it will be lifted by the saddle carrier, which you will see the next picture. Next. So what you are seeing here, this is a saddle carrier. It can lift the entire 40-meter span at one go with 4 legs, and then there is a frame. It's nothing but like a moving gantry, kind of with a arrangements within a wheel, everything. So you require a good foundation, good support, everything is required perfectly. And what you see the right hand side, which is the including bottom mold, bottom shutter, and sides is being fitted to positions. And this, the saddle carrier carrying the jigs reinforcement, it will lift and then place it on this one. Next. Now you can see the concreting. The entire thing is being concreted. Of course, on the left hand side, you see one more inner mold. That's what maybe I have not explained. So that is the inner mold, which already there inside. So here this concreting is going on within a complete pump, because the concrete in the range of about 400 to 450 cubic meters. So it will be like a continuous, you have to finish it within about 8 to 10 hours, because otherwise you will have more cold joint and maybe about various other issues will be there. So it should be done very nicely. You have to do it within a sequence of concreting such a way that you should not land up within a cold joint. You don't land up with the any other, rather the fast setting. So you have to have more precautionary measures. Next. So after you have done that, you have to do that initial stressings, everything, cross pre-stressing, then lift the segments using the same the saddle carrier and place it in the stacking yard. Next. Now you can see that, you can see closely, there is a pier is there in the background. This is a first span gantry. You can call them as a bridge gantry. It lift inside of it where this, the saddle carrier will place it in plan side of the erecting spans. So lift this by bridge gantry and place it on top of the pier cap, so that few spans will be erected using this bridge gantry, and thereafter every span will be lifted on top of it over the especially made the trailers. Rather, it is a carrier. We call them as a carrier. Next. Yes, you can see on top of the deck a small so many tires, or you can see that, which is a specially designed transporter. On top of it, it will be kept by, and left hand side what you see the bridge gantry, and then the right hand side what you see the blue color, which is the full span gantry, that is the bridge gantry. So that will have an arrangement, lift from top of the the carrier and then roll it over within itself and then place it on the next pier locations, these spans. So this entire operations being done even in a day, it can do two also. That kind of mechanized, completely, motorized, everything is there. So that is the specialty of this kind of structures. That means in a month, you can do about 25 to 40 spans. So that much, almost in a kilometer, you can run with this one machines. Next. So now come back to that, this kind of the latest construction techniques, what it is going to give a benefit. One is a less manpower, because people intervention is very low. You don't require huge number of people do the staging, shuttering, reinforcement, fixing, everything will be done parallelly. Of course, you need to do the shuttering, which is one precast yard, prefab, earlier itself has been, done within a proper design. So you just do it, clean it, and then kept ready. The labor required for the reinforcement, independently they do with the jigs and then tie that everything with as per the drawings, as per the detail, including sheathings, everything they will fit it at the, on a pre-locations and then bring it. The next one is, I think you require these people to be trained properly, how to operate the shutters, how to operate that, this reinforcement bay, everything. So that is important, so that, to do that. You don't require about to do the in-situ construction, but at least the precasting is done. Third point is, I think, repeated. This is going to be repeat, because you don't require to do every time, one location to other location. So it's a repeated. So people will get used to it. And also you have a very controlled environment. So better qualities, better kind of, the enhancing the productivity also possible. When you talk about this, if you do it in situ with open yard, rather, like at site. So that means you have to have a proper, again, arrangements, everything will be required, which is going to cost even weather or any other issues, which will have a different, rather, other problem will be there, particularly traffic management and all. So that way it will be about this kind of methodology will be faster and also maybe economical. Next. Now, what are the challenges we have? Now, these kind of equipments, particularly, is not to be ordered. And also when you order, it's really taking more time, and also it is much, much expensive. In terms of the, budget, it will be much higher cost. And so you have to do that. So you can't expect it, in one project, this will going to be right off. You require a couple of projects so that at least you can share this cost or other, bifurcate this cost. Of course, government is now today really looking for about such a development in bullet train. There's a lot of, I think, DBR is going on various major cities to be connected. So it's a good sign, so that at least we can do this investment, we can get back something. Of course, a lot of people now start entering. Everyone is really wanted to have an, rather contribution rather into doing these jobs. So bids are more competitive. The continuous training is required for these people, not only manpower of workers as well as staff, also to be upgraded. So that this technology, this kind of construction, which is going to be different from the normal type of construction. Another big benefit is, this utility shifting, particularly in this site rather in this one, which also having, more challenges where, that it takes one electrical, the heavy, 220 kV and 400 kV, and shifting itself is going to be a bit challenges. So those things also, project where you do not have any other choice because this development is taking place. Earlier, wherever I think, this line is being connected, this rerouting has to be done, everything. So these are the bit of challenges where we foresee that. Next. Now, what lessons we have been, probably, seen that in the particularly this particular precasting and then success of the project. One is you have to well plan any project, this particular one like a bullet train, which we are doing about, a couple of projects where we need to plan where is the precast yard, how you are going to rather, do this constructions, and what is the number of mode, number of launcher, number of saddle carrier. These are all to be well planned. And for precast yard, this is not a precast yard, which will show you some couple of photos, how big this precast yard. Each one will be about, almost about in the range of about 70 to 100 acres. So where to get, how do we get it? And where is the land? That's going to be big challenges because most of the things are all greenfield, where the ROW, they are taken it is only about maximum 10 to 12 meter, 15 meter, which is not good enough for the precast yard. You require about huge land. So that is a big challenge, kind of requirement is to be done. The next one is the, getting these fabrications of mold, launching girder, gantry, which is almost run into that, more than about, 15, 20,000 tons of fabrications. And also time, it needs more time. So, and coordination, engineering, everything is going to be a bit of challenges there. Of course, whatever we planned during the bidding, number of, segment produced, number of span erected. So these are all little bit, whatever the planning is being done, whether it is going to be get achieved. So what kind of, the management decision is required, or sometimes, yes, you require additional mode, you have to get it. Because as far as the employer is concerned, fixed time. This is the time you have to get that whole thing. So that is one more challenge. The next one is if you don't do proper stacking, proper by, on land is not available. So why not we store it in a different, then there is going to be challenges. This segment is all very sensitive. You can't do it whatever you like it. So you have to take into that, that what intent for the designs. So these are the, whatever we feel, felt the project where which is being carried out, some of the things which is, lessons which we have been come across that. Next. I think we'll show you some of the photograph of this, how big this precast yard. This is in a Ganga project. It's almost more than about, 9-10 kilometers of extra dose cable stay bridge. So the precasting is being done with so many gantries, launcher and all. Next. There is a bullet train where this full span construction is going on, big way, big scale. So you can see that the way in which is more than I think, 70, 80 acres land. Yeah, next. So that's it. So I just wanted to touch upon this construction of the new technology, technical things is going on there.
Thank you, Mr. Sankaralingam. We already have several questions for you,
Sure.
and I think we can spend next 5-7 minutes on addressing those. We have a question from Mr. Gaharwar. He is saying that recently a number of failures have been reported of under construction bridges, including those of failure of bridge deck launchers. So what could be the probable reasons for such failures in general? And, if you could tell us a little about the precautions that must be kept in mind to avoid such failures.
See, which I told you that I think one of the things, this is being repeated natures. When you do the repeated natures, the people also feel that probably felt, oh, this is the same work I'm doing. So the lethargy. That means the people to follow certain procedures. I'll tell you, normally all these segmental constructions where the edge surface has to be completely the sandblasted, because the two surface which is going to meet and join together within a glue joint, you have to have a proper sandblasting, make it a rough, and then apply this glue, uniform thickness, and join together and squeeze out this glue. So end of the day, this thickness of glue will be not more than 1 mm, because there is some thickness will do. If they don't do it properly, what happened was, this is the first place where the problem happening for the opening of the cables, or if it is not fully contact, then there is a stress level is going very high, because all these structures, what are being done, designed by the people, these are all not something about 40%, 50% stresses. It's all more than 70, 80, 85% stresses. So you do not have too much of play for construction, rather, the accuracy. Yes, if the thickness of the web, if it slightly goes plus or minus, it doesn't matter. But construction point of view, whatever it is being stated very clearly with match casting and line and levels and compaction of the concrete properly with the M40 means M40 or M50 means M50. If they are not done properly, the anchorage location, if they are not done properly, then all this problem happen. If we really go into the sea, all this failure happen even with our L&T also. We have a couple of issues. We have been come out of it. Now we really enforcing each and every project with more training and more quality control. And these two things only which is going to be helpful for this kind of technology. Otherwise, this so much of technology which is being carried out, or rather it is being started introducing, which is not going to be effective, which is going to be waste. So which is required? One is the quality control and more supervisions, as well as training of their workmen and staff.
Right.
The responsibility should be taken by the people.
Right. So we have another question from Mr. Pranab Barua. He's asking, what is the monitoring system or a checklist put in place to account for damages or wear and tear during lifting or placing or transportation of the precast full span bridges?
See, basically, these segments are all very, very sensitive. So when you transport it, exactly where you are going to place that your support is to be very clear, should be predetermined. And also, whenever you are lifting these segments, so there is a design in which strong back to be used, and lifting means you are using the structural frame, which McAlloy bar, you do the stressing and lift through this exact location of the place. So these are all predetermined places, only you have to do it during the lifting, during the transportations time. So that will be all left out, rather given by the designers or other construction designers. They will be able to decide, so that it will be checked, the stresses, including this reinforcement adequacy, everything will be done. Then only will be allowed them to do that.
Right. So this is the last question. It's not a question, it's more like a comment from Mr. Sama Srinivas. He's saying that in North America, there are pre-tension and not post-tension beams for standard sections. Sections such as I-beams, L-beams, etc. are very common for medium span bridges in the North American region. So he's just asking that, why is that not common in Asia? And, if you've planned certain sections in your Asian infra projects, or are you planning to do that?
In fact, we are doing plenty. It's not that. Of course, I have not covered this, particular topic in half an hour. What you expect to show? I thought maybe the latest one. Retention is age old. Even I think, if you talk about our Mumbai-Pune expressway, I'm talking about where we built in 90s. All are pre-tension girders. Today also we are doing. Pre-tension girder is very good when the repetition is been more than 500 girders. Then there is a cost effective. Otherwise, post-tension is better. If it is a 30 meter, 35 meter spans, high girders. All the flyovers built by in Mumbai, everything is pre-tension or post-tension girders. It's not that I think we do not, rather it is not been a practice. It's a lot of practice going on. Right now, whatever project we are doing, Mumbai, I think, Mumbai, Ahmedabad Expressway, all are pre-tension girders, more than 900 girders. Almost one particular job, we have converted a tunnel into vertical wall and pre-tension girder top and top deck slabs. 3,000 girders, we are doing the pre-tension girders. Every day we do about more than 20 girders. So scale is in big way. That is no issue at all. 30, 35 meters, it's like simple thing. And it's not a big, rather I will say that I think, very high tech. I can say it's the normal procedures of small bridges up to 30 meters, 35 meters. Pre-tension girder is very common.
All right. So we do have two more questions. So, I'll just request you to be a little brief there. One is from Mr. Venkat Subramani. He's asking, what is the lifespan of these precast bridges?
See, the design life is 100 years, design life. Now, how do you ensure this 100 years life? When the designer is being done design, how do you do it in construction with material selections and the construction procedures, methods being done, including that, I think, some of the monitoring systems. So basically, the durability criteria where the mixed design is being followed and what material selection is being followed. Our MORTH code is very, very, very clear. Very clear. This is the minimum requirement of rather aggregate to be used, cement to be used, steel has to be followed up, everything. And the clear cover has to be provided and the stressing level has to be given to that. I'm 100% sure. I think this will be there in the first bridge we built in Kongan Railway. It's almost now 96. Now till date, we don't see any such issues. It's almost more than 29, 25, 30 years over.
Right.
No issue. Whatever is being done, these are all designed for more than 100 years, intact, no problem.
Okay. So there's another question on what is the glue material that is used in segmental construction?
It's epoxy glue, which is being produced by, there are the earlier days, I'm talking about, 94, 95, we started in Sisi flyover, Sika, which is all imported this glue from abroad. Now they indigenized. There are many people at the Sika, Force Rock. There are so many agencies are there. It's all two base. One is the hardener, one is the, the base. So these two things which will be mixed together, pot life is only 35 to 40 minutes. Within that, you have to apply, and otherwise it becomes harder. So within this period, it should be applied. So again, temperature control. There are 2-3 type of temperature is there. One is up to 30, other one is 30 to 40, and above 40. So there are 3 types are there, which will be depending on the environment during the construction time, what temperature we need to operate. So you would pick up that particular times.
Thank you, Mr. Sankaralingam. With that, we're going to close this session. I'm sure everybody would agree that it was a very informative presentation and, it was a very interactive conversation with people getting their comments and queries addressed by you. Thanks a lot for your time, sir. Thank you so much for being here with us today.
Thank you. Thank you. I believe this is the last one. Anyway, all the best to the, participant. Hope, I think they enjoyed as well as they learn, at least take away from something from their, this kind of 2 days program. All the best to everybody.
Thank you. We did not have a single drop, sir. So all the delegates are intact, which means that this presentation was very interesting.
Very
Thank
good.
you. Thanks.
Thank you. Thanks.
And with this, we have come to the close of this two-day event, which is the second edition of our virtual conference on bridge construction in Asia. I would like to extend a big thank you to all our speakers for making both the 2 days extremely informative for all our delegates. And at the same time, I would like to extend my thanks to all the delegates as well for making all the sessions very interactive and participative. Of course, we owe a big thank you to Web System International for sponsoring this event. It has been made possible partly with their support. And with this, I would like to close today's proceedings as well as this conference. Thanks again for your time and for being here with us today. I would request all the delegates to please share their feedback, their comments on the chat or the Q&A space, which will help us, improve on our events going forward. Well, there are a lot of requests for PPT sharing. We are in touch with all the speakers, because since they have shared it from their respective screens, allow us a day or two to collect those presentations, and then we will be circulating them as and when we get them. Thank you. Have a good day. Thank you.